In this 3-hour course, you're going to learn everything you need to get started with SQL or SQL. First, I'm going to give you a 3-minute introduction to SQL. Then we're going to install the necessary tools and write our first SQL query. This course is ideal for anyone who wants to learn SQL from scratch, but also anyone with some basic knowledge who wants to fill in the missing gaps. By the end of this course, you'll be able to retrieve, insert, update, and delete data in databases. We'll talk about tables, relationships, different types of joins, subqueries, regular expressions, and much more. These are the essential concepts that every software developer or data scientist must know. This SQL course is packed with tons of exercises that help you both learn and remember the SQL syntax. Also, there is a table of content below this video, so you can quickly jump to specific tutorials. Now let's jump in and get started. Let's start the course with a quick overview of databases, what they are, and how we use them. A database is a collection of data stored in a format that can easily be accessed. In order to manage our databases, we use a software application called Database Management System, or DBMS. We connect to a DBMS and give it instructions for querying or modifying data. The DBMS will execute our instructions and send results back. Now, we have several database management systems out there, and these are classified into 2 categories: relational and non-relational, also called NoSQL. In relational databases, we store data in tables that are linked to each other using relationships. That's why we call these databases relational databases. Each table stores data about a specific type of object, like customer, product, order, and so on. SQL or SQL is the language that we use to work with these relational database management systems. It looks like this. We use SQL to query or modify our data. In this course, you're going to learn everything about this powerful language. Now, there are many different relational database management systems out there. Some of the most popular ones are Mysql, SQL Server by Microsoft, and Oracle. But of course, there are plenty more. Each database management system has a different flavor of SQL, but all these implementations are very similar and are based on the standard SQL specification. So most of the SQL code that you will learn in this course will work with any database management system. In this course, we'll be using Mysql, which is the most popular open source database in the world. All right, now back to this diagram. What about non-relational databases? In non-relational databases, we don't have tables or relationships. These databases are very different from relational databases, but that's a topic for an entirely different course. What you need to know is that non-relational database management systems don't understand SQL. They have their own query language. So we use SQL to work with relational database management systems. Now, before we jump in and install MySQL, let me clarify something quickly. As you talk to different people, you will hear 2 different pronunciations of SQL: SQL or SQL. What is the correct way? Well, it depends on who you ask. And of course, everybody thinks their way of pronouncing this word is the right way. But here's a little history about this language. SQL was originally developed at IBM in the 70s, and back then it was initially called SQL, short for Structured English Query Language. But they changed the acronym to SQL because SQL was the trademark of an airplane company. So to this date, there's been an argument about what is the right way to pronounce this language. Generally speaking, people in non-English speaking countries call it SQL. I'm used to calling it SQL because it's shorter and sweeter than SQL. But if you prefer to call it SQL, that's totally fine with me. I'm not going to get mad at you. So that's the history behind this language. But what about MySQL as a software product? Developers of this product prefer to call it MySQL rather than MySQL, but they don't mind if we call it MySQL. In this course, I'll be teaching you SQL with MySQL. Hey guys, Mosh here. I just wanted to let you know that you really don't have to memorize anything in this course because I have created a complete cheat sheet with summary notes for you. You can find it below this video in the description box. So I have done my best to create the best possible, most comprehensive SQL course for you, and I would really appreciate it if you support my hard work by liking and sharing this video. Thank you so much. Now let's continue. In this tutorial, I'm going to show you how to install MySQL on your computer. Now here I'm using a Mac, so first I will show you how to install MySQL on a Mac computer, and then I will show you how to install it on Windows. So if you're a Windows user, feel free to skip this tutorial. Now, open up your browser and head over to mysql.com. Then go to the downloads page and scroll down to the bottom. Here you should see MySQL Community Edition. This is absolutely free, and we're going to use that throughout this course. So let's go ahead with that. Now on this page, click on MySQL Community Server. And then on this page, you should see available releases for Mac OS. So in this list, download the first item, which is a DMG archive. All right. Now on the next page, click on No Thanks, just start my download. All right, as you can see, we are getting a DMG file, which is basically a setup wizard. All right, now the DMG is downloaded, so let's open it and then double click on this package. This will launch an installation wizard, which is pretty easy to use. So simply click on Continue and again and again. I agree with the license agreement and install MySQL. It's going to ask for your password. This is the password that you use to log into your computer. So let's put that here. All right. Now here we need to set a password for the root or the admin user. So click Next, and in this box, type a complex password. All right, now let's finish the installation. And enter your computer's password one more time. And we're done. That was super easy and sweet. All right, we installed MySQL Community Server. Now we need a graphical tool to connect to this server and manage our databases. So back to the downloads page. One more time, scroll to the bottom and go to MySQL Community Edition. And on this page, somewhere you should see MySQL Workbench. This is a graphical tool that we use to connect to our database server. So let's go ahead and download this as well. Now, once again on this page, we need to download a DMG archive. So download. And again, we have to say, no, we don't want to log in or sign up. So let's just go ahead and download the DMG. And then open it. All right, you're going to see something like this. So simply drag this MySQL Workbench and drop it onto the applications folder. So let's go ahead with that. Now this is going to copy this into the applications folder. Beautiful. So we're done with the installation. That was super easy. Now press Command and Space and search for MySQL Workbench. There you go. Let's open it. Now the first time we get this message, because this is an application that we have downloaded from the internet. So we need to tell Mac that we trust this. Let's go ahead with that. So this is MySQL Workbench. Now by default, you should see a connection here. If you don't see that, you need to create it. Let me show you how to do that. So for this demo, I'm going to right click this and delete this connection. All right. Now let's create a connection from scratch. So click on this plus icon. On this page, give this connection a name. Let's say local instance. Now the connection method that we're going to use is TCP/IP, which is set by default. The host name is 127.0.0.1, which is the address of the local machine. And the port is 3306. This is the default port for MySQL Server. That is the username of the admin. Now we need to enter the password. This is the password that we set during the installation. So click on Store in Keychain. And in this box, type the password for the MySQL Server. All right. And finally, let's test the connection. Okay, we successfully connected to MySQL Server on the local machine. Beautiful. Let's click OK. And here we have a connection on the homepage of MySQL Workbench. Every time we open MySQL Workbench, we use this connection to connect to our local server. All right, we're done with the installation of MySQL on a Mac. Next, I will talk about installing MySQL on a Windows computer. So feel free to skip that tutorial. In this tutorial, I'm going to show you how to install MySQL on Windows. So open up your browser and head over to mysql.com. Then go to the downloads page. Now here, scroll down to the bottom. We're going to use MySQL Community Edition, which is absolutely free. So let's go with this. Now select MySQL Community Server and then scroll down. So here you should see something like this, MySQL installer for Windows. This is the recommended method for installing MySQL on Windows. So click on this. All right, on the next page, scroll down and download the first installer here. On the next page, scroll down and click on no thanks, just start my download. Otherwise, you have to create an account and log in, which is unnecessary for following this course. So let's go with this and save this file to our computer and then run it. All right, we're going to use this setup wizard to install MySQL on our computer. This is very easy. All you have to do is to click next. But there are a couple of places where you need to enter a password. Let me show you. So on the first page, for the setup type, we're going to use the developer default setup. Go to the next page. Now here we're getting a little warning because this installation wizard wants to install the connector for Python 3.7. But I don't have Python on this machine, so that's why I'm getting this warning. Now on your machine, you might or you might not get this error. It doesn't really matter. Just click next and one more time. So here are the products that are going to get installed. The first one is MySQL Server. The second one is MySQL Workbench. This is the graphical tool that we use to connect to our database server and manage our databases. You're going to see that soon. So click on execute. Now this is going to take about 5 to 10 minutes. So I'm going to pause the recording. All right, all the products are installed. Beautiful. Let's go to the next page. And again, here on the group replication page, also click on next. On the next page, which is about networking, leave all the default settings. So let's go to the next page. Now we should set a password for the root or the admin user. So click on next. And in this box, type a password for the admin user. All right, and then let's go to the next page. Once again, leave all the default settings and click on next and execute one more time. All right, and now let's finish the installation. Once again, we have to click on next and then finish. And one more time, there's so many steps. Now here's the page where you need to enter the admin password. So the page is called Connect to Server. You can see the username is root, which represents the admin user. So in this box, enter the password that you set earlier, then click on check. Okay, connection was successful, beautiful. Let's go to the next page and click on execute and finally finish. There you go, we have one more step. Next. Now finally, after all these steps, the installation is complete. Now this is going to start MySQL Workbench, which is the graphical tool we use to manage our databases and run SQL queries. So click on finish. So now we have a command prompt window where we can type instructions to talk to our MySQL server. We don't really need this, so close it. And here's MySQL Workbench. Now the first time you open this page, by default, you should see a connection here. If you don't see it, click on this plus icon. On this page, give this connection a name. Let's say local instance. Now leave all the settings to their default value. But here for the password, click on Store in Vault. And in this box, type the password that you set for the admin user. So I'm going to put that here. Okay. Now click on Test Connection. All right, we successfully connected to the MySQL server on this computer. All right. Then click on OK. Now we click on this connection to connect to our database server. All right. So here's the interface that you'll be using throughout this course. On the left side, we have the navigator panel. In the middle, we have the query editor, which we can resize. This is where we're going to write our SQL queries. And on the right side, we have SQL additions. So we're done with the installation of MySQL on our computer. Next, I'm going to show you how to create the databases for this course. In this tutorial, I'm going to show you how to create the databases for this course. So here I've got MySQL Workbench open. Let me quickly give you an overview of this interface because the first time you open it, it might appear a little bit intimidating, but actually it's not that difficult. So here on the top, we've got this toolbar with these buttons for creating a new tab for writing SQL code, as well as opening a SQL file. And next to that, we've got a bunch of buttons for creating a database, creating new tables, and so on. On the left side, we've got the navigator panel with two tabs, administration and schemas. We use the administration tab to do administrative work, such as starting or stopping our server, importing or exporting data, and so on. The schemas tab shows the databases that we have in the current database server. So currently we only have one database, that is sys, and this is the database that MySQL uses internally to do its work. Now in the middle, we've got this query editor window. This is where we write our SQL code. So we'll be spending most of our time in this course in this window. And on the right side, we've got another panel with two tabs, context help and snippets. The chances are this interface might look slightly different on Windows, but what I'm showing you here is almost identical with what we have on Windows. So don't get hung up if it looks slightly different on your machine. It doesn't really matter. Now up here, we've got these buttons for showing or hiding these panels. So to clean this interface, I'm going to hide this panel on the right side, as well as the panel on the bottom. That is better. Now to create the databases for this course, download the zip file I've attached below this video. When you extract this zip file, you're going to see a bunch of SQL files like this. So the main one that you will be using in this tutorial is called createdatabases.sql. So this file contains all the SQL code to create all the databases that we need in this course. Now we also have individual files for creating individual databases. I just added these files in case you need to recreate one of these databases in the future. But for now, don't worry about them. Now, back to MySQL Workbench. Let's open the main SQL file, that is create databases. So this is an example of SQL code. Now, this may look complex at the beginning, but trust me, as you go through the course, you're going to understand exactly how everything works here. You're going to be able to write SQL code like this. So we want to execute this to create all the databases for this course. To do that, we click on this icon, this yellow thunder icon that we have on this toolbar here. This will execute either the selection or the entire code if there is nothing selected. For example, if I select this line here and click on this icon, this will execute only this line. In this case, we want to execute the entire code, so we shouldn't select anything. And now let's execute this. Beautiful. So here down the bottom, we have this panel called the output window that shows all the operations performed in our database server. So we can check to see if all the operations completed successfully or something went wrong. As you can see, we've got these green ticks next to each operation. Beautiful. So I'm going to close this panel. That's better. Now on the left side in the schemas tab, currently we don't see the new databases. So we'll have to refresh this view. Beautiful. So we've got all these databases that are prefixed with SQL or SQL. I decided to prefix them with SQL so we know that these are the databases for this course. They don't accidentally clash with another database with the same name on your database server. Now, at the time of recording this video, there are only 4 databases here, but as we go through the course, I'm going to update the script for creating the databases. So when you watch this course, chances are you're going to see more databases here. Don't worry about the difference. Now, as an example, let's explore one of these databases. And by the way, we don't need this tab anymore, so let's close it. That's better. Let's expand the SQL store database. Now, in every database, we have these objects. We have tables. This is where we store our data. We have views, which are kind of like virtual tables. So we can combine data from multiple tables and put them in a view. And this is especially powerful for creating reports. You're going to learn about them in the future. We also have stored procedures and functions. And these are little programs that we store inside of our database for querying data. For example, we can have a stored procedure for getting all the customers in a given city. So we call that procedure and say, hey, give me all the customers in San Francisco. And this will return all the customers in San Francisco. Okay. Now let's expand the tables. So here are the tables in this database. We have customers, we have orders, products, shippers, and so on. Now select this customers table. Whenever you hover your mouse over this item, you should see these three icons on the right side. Click on the rightmost icon that looks like a table with a thunder. With this, we can see all the data in this table. So this is our customers table. In this table, we have these columns like customer ID, which we use to uniquely identify customers. We also have first name, last name, birth date, phone, address, and so on. So these are the columns in this table, and every row is called a record. So every row represents one customer, and these are the pieces of information we know about each customer. Now let's look at another table. Let's open the orders table. In this table, we have these columns like order ID, customer ID, order date, status, and so on. What is this customer ID here? We use this column to identify who has placed each order. Now, what is interesting here is that you're referring to these customers using their customer ID, which uniquely identifies them. In other words, if John Smith has placed an order, we don't store John Smith here. We only store John's customer ID. Why is that? Here's the reason. It is possible that John Smith might have placed multiple orders in our system. Now, every time John places an order, we need to look up his address and phone to ship his order. Now, it is possible that some of this information might change in the future. John might move to a new place or change his phone number. He might even change his name. If we repeat all that information next to each order, then we'll have to come back and make changes in multiple places. In contrast, with this design, we only store the ID of John here. So anytime we want to change any information about John, instead of changing that here, we go back to our customers table. So let's look at the customer with ID 6. That is actually called Elka. So here are all the information about Elka. This is her phone number, this is her address, and by the way, this is all dummy data that I created using a tool. So if any information about Elka changes in the future, this is the only place that we need to modify. So this is how these databases work. We refer to these databases as relational databases. That basically means in this kind of databases, we have multiple tables that are related to each other using a relationship. So internally, there is a relationship between the customers table and the orders table. So the customer ID column in the customers table is related or linked or associated with the customer ID column in the orders table. Here's the orders table, and here we have the customer ID column. So this was a brief introduction to relational databases. You learned about databases, tables, columns, rows, and relationships. In the next section, I'm going to show you how to retrieve data from a single table in this database. But before going any further, as an exercise, I want you to explore the invoicing database. Look at all the tables, look at all the data to get an idea of the kind of data we have in this database. We're going to use this database a lot in the future. So we'll spend a couple of minutes to explore this database. In this tutorial, I'm going to show you how to retrieve data from a single table. Now look at the navigator panel. Currently, none of our databases is displayed in bold. That means none of these databases is selected for querying. So the first step to write a query to get data from a database is to select a database. The query that we'll write will be executed against that database. In this demo, we're going to use this SQL store database. So we type out use SQL _store. Now, use is a keyword in the SQL language, and that's the reason it's displayed in blue. Now, SQL is not a case-sensitive language, and that means we can use uppercase or lowercase characters. It doesn't really matter, but as a best practice, we should capitalize the SQL keywords and use lowercase characters for anything else. So now let's go ahead and execute this query. All right, look, this SQL store database is now displayed in bold. Now in MySQL Workbench, you can also select a database by double-clicking that. So now I double-clicked SQL invoicing and it's the current database. Now if we run this query again, the SQL Store database becomes selected. All right, now let's write our first query to retrieve all the customers in this database. So after the use statement, we're going to use the select statement. Here's the basic syntax or basic structure of the select statement. We type out select. In front of that, we specify the columns that we want to retrieve. For example, we can retrieve the customer ID column as well as the first name column, or we can retrieve all columns using an asterisk. Now, after that, we use the from clause, and this is where we specify the table that we want to query. In this case, the customers table. So this is the simplest query to select all the customers in a given table. Now, whenever you have multiple SQL statements, you need to terminate each statement using a semicolon. So look, we have a red underline here that indicates an error. If you hover your mouse here, you can see this tooltip saying select is not valid at this position because we didn't terminate the first statement with a semicolon. Okay, now let's execute this query one more time. Once again, we can click on this button here, or we can use a shortcut. So look at the query menu on the top. The first item is execute. Now here's the shortcut for this command. On Mac, it's Shift, Command, and Enter. On Windows, it's going to be different. Honestly, I'm not sure. So whatever it is, use that. So I'm going to press Shift, Command, and Enter. And here are all the customers in this table. So this select statement has two clauses, the select clause and the from clause. But there are other clauses that we can use to filter and sort data. For example, we can use the where clause to filter the result and get the customer with ID 1. So we can write an expression like this, where customer underline ID equals 1. Now when we execute this query, we'll only get the customer with ID 1. So this is the where clause. We can also sort the data. So after where, we use the order by clause. And here we specify the columns that we want to sort the result on. Let's say we want to sort these customers by their first name. So we type out first underline name. That is the name of one of the columns in this table, right? Now, if we execute this query, this order by doesn't really have any impact because we only get one record in the result. So let me temporarily take out the where clause. To do that, we can put two hyphens in front of this line. Now this line is treated as a comment, which means the SQL engine is not going to execute this. Okay, so let's execute this query one more time. Now all the customers that we get are sorted based on their first name. So that's the basic idea. Now over the next few tutorials, you're going to learn more about each of these clauses in detail. But what you need to take away in this tutorial is that these three clauses, from, where, and order by, are optional. As you can see, in this example, I'm not using the where clause. We can also comment out the order by clause. We can also comment out the from clause. So instead of selecting all the columns in a given table, we can select some values like 1 and 2. Now, if we execute this query one more time, in the result, we get something like this. Two columns called 1 and 2. And in these columns, we have these values. So all these clauses are optional, but in the real world, we quite often use all of them. Now, what you need to understand here is that the order of these clauses matters. So we always have select first, then we have from, then where, and finally order by. We cannot change the order of these clauses. Otherwise, we get a syntax error, which basically means the syntax or the grammar or the structure of our SQL statement is incorrect. So it can't be executed. And one last thing before we finish this tutorial. In this example, you can see I've listed all these clauses on a new line. Now, technically, you don't have to do this because line breaks, white spaces, and tabs are ignored when executing SQL statements. So we could come back here and put from in front of select. So select star from customers all in one line. And that's perfectly fine for simple queries. But as your queries get more complex, it's better to put each clause on a new line. So that's all for this tutorial. In the next tutorial, we'll explore the select clause in detail. In this tutorial, we're going to look at the select clause in detail. So since our current database is SQL Store, to clean things up, I'm going to remove the first statement. We don't really need it now. Also, I'm going to delete these two comments. We just want to focus on the select clause. All right. So what can we do with this select clause? Well, in the last tutorial, you learned that if we use an asterisk, this will return all the columns. Alternatively, we can specify the columns that we want. And this is helpful in situations where you have a big table with so many columns and perhaps millions of records. If you want to bring back all that data, that's going to put a lot of pressure on the database server, in this case MySQL, as well as the network. So that's when we explicitly specify the columns that we want to get. Let's say we want to get the first name and last name columns. Execute the query. As you can see, we only get these two columns, and they're in the same order we specified here. So if we change the order and put the last name first and execute the query again, now you can see the last name column comes first. Now let's add a new column to the end. Let's get the points for each customer as well. Run the query. So these are the points for each customer, which are calculated based on their shopping. Now let's say we want to get these points and put them in a mathematical formula to calculate the discount that we can give to each customer. So here we can use an arithmetic expression. Let's say points plus 10. This is an arithmetic expression. So now if we execute this query, for the first record, you can see that their points will end up being 2283. Let's run the query one more time. There you go. Now we can put the original points column here for clarity. So points, comma, points plus 10. Let's run the query one more time. Now you can see the original points, and next to that, you can see the value that we're going to use to calculate the discount. Now here we're using the plus operator, which is for addition. We also have multiplication, division, subtraction, and modulo, which is the remainder of the division. So let's change this to something more complex. Let's say we want to get the points multiplied by 10 and then add 100 to it. Now you can immediately see that this line 1 is getting too long and it doesn't fit on the screen. In situations like this, you can break up the select clause by placing each column on a new line. So select last name, then first name, points, and finally points times 10 plus 100. So let's execute this query one more time. So this is our new column with the new calculated value. Now, one thing you need to understand in this arithmetic expression is the order of operators. And this is based on the order of operators in math. So in math, the multiplication and division operators have higher order or higher precedence than addition and subtraction. So in this expression, first points is multiplied by 10, and then the result is added to 100. Now, if this is not what you want, you can always change the order by using parentheses. As an example, let's change this multiplication to addition and then put that multiplication here. In this expression, first 10 is multiplied by 100 and then the result is added to the points. Now let's say this is not what we want. So we can change the order by using parentheses here. With this parentheses, first we get the points, add 10 to them, and then multiply the result by 100. So these parentheses are useful for changing the order of operations as well as adding clarity to our code. So someone else reading this code can easily understand the order of these operations. Now let's execute this query one more time. All right, now look at the name of this column here. It's set to the expression that we have on line 5. That doesn't quite make sense. We want to have a clear descriptive name. So we can give this column an alias using the as keyword. So as, and then we give it a name like discount underline factor. Let's run the query again. Now the name of this column is changed. So this is the benefit of using an alias. We can give descriptive names to the columns in the result set. Now, if you want to have a space in the column name, you need to surround it with quotes, either single or double quotes. So we put quotes here and then we can add a space in between these two words. Let's execute the query one more time. Now we've got discount factor. So let's quickly recap everything you learned about the select clause. We can use an asterisk to return all the columns, or we can explicitly specify the columns that we want to return. We can also use arithmetic expressions here, and optionally we can give an alias to each column in the result set. Now there's one more thing you need to know about the select clause. So let's delete this query and select the state column from the customers table. Take a look. These are the states in which our customers are located. Now, currently in the sample data, we don't have any duplicates. In other words, we don't have multiple customers in any of these states. But for this demo, I want to change the state of the first customer to Virginia, so we end up with duplicates in the result set. So let's open up the Navigator panel. Here's our customers table. Let's look at all the data. And here's our first customer, as you can see, is located in the state of Massachusetts. Now I want to change this to Virginia. So double click VA for Virginia, enter, done. Now on the bottom right corner of the screen, you should see two buttons, apply and revert. Unfortunately, I cannot show you these buttons because the recording window is a bit smaller than Mysql Workbench. But look down the bottom, in the bottom right corner, click on apply. You're going to see a dialog box like this asking you to review the changes. So go ahead and click the apply button one more time. All right, beautiful. Now, let's go back to our first query window and execute this query one more time. As you can see, the first two customers are located in Virginia. What if we want to get the unique list of states in the result set? That's when we use the distinct keyword. So select distinct state. With this query, we'll retrieve the unique list of states from the customers table. So with the distinct keyword, we can remove the duplicates. Let's execute the query one more time. Now you can see Virginia is not duplicated. All right, here's an exercise for you. I want you to write a SQL query to return all the products in our database. In the result set, I want to see three columns: name, unit price, and a new column called new price, which is based on this expression, unit price times 1.1. So let's say we want to increase the price of each product by 10%. With this query, we want to get all the products, their original price, and their new price. So pause the video and spend 1 or 2 minutes on this exercise. When you're done, come back, see my solution. All right, this is pretty easy. So we start with select. Now, what columns do we want to select? Name, unit, underline price. And then here we're going to use an arithmetic expression to calculate the new price. So we type out unit price times 1.1 and then give it an alias. So as new underline price, or we could put this in quotes and put a space between new and price. Now, where do we want to select these columns from? From the products table. So from products. Note that I've used uppercase characters for all the SQL keywords and lowercase characters for everything else. So let's go ahead and execute this query. This is what we get. So these are all the products. You can see their original price as well as the new price, which is 10% more expensive. In this tutorial, we're going to look at the where clause in SQL. So earlier I told you that we use the where clause to filter data. For example, let's say we only want to get the customers with points greater than 3,000. So here in the where clause, we can type out a condition like this: points greater than 3,000. When we execute this query, the query execution engine in Mysql is going to iterate over all the customers in the customers table. For each customer, it's going to evaluate this condition. If this condition is true, it will return that customer in the result set. So let's go ahead and execute this. And here's the result. As you can see, we have only 2 customers with points greater than 3,000. So this is what we call the greater than operator, which is one of the comparison operators in SQL. Let me show you the complete list of comparison operators. So we have greater than or equal to. We have less than or equal to. Here's the equality operator. And for not equality, we can use an exclamation followed by an equal sign or something like this. So both these are not equal operators. Let me show you a few examples of these operators. So I'm going to delete all this and bring back the previous query. Let's say we want to get only the customers in the state of Virginia. So we can change our condition to something like this, where state equals Virginia. Note that I have put Virginia in quotes because this is what we call a string. A string is a sequence of characters. So whenever you're dealing with a sequence of characters or basically textual data, you need to enclose your values with either single or double quotes. But quite often, by convention, we use single quotes. So let's execute this query. And here's the result. You can see we only have these two customers with ID 1 and 2 who are located in Virginia. And it doesn't matter if we use uppercase or lowercase characters. So if we type out VA in lowercase and execute the query, we get the exact same result. Now, what if we want to get all the customers outside of the state of Virginia? We can use the not equal operator. So we can either prefix this with an exclamation or use this other notation. Either way, we get the same result. So these are the customers that are not located in Virginia. Now we can use these comparison operators with date values as well. For example, let's say we want to get only the customers born after January 1st, 1990. So we change our condition to birth date greater than. Once again, we use quotes for representing date values, even though dates are actually not strings. But in the SQL language, we should enclose dates with quotes. So here we type out 1990-01 for January-01 for day. So this is the standard or the default format for representing dates in Mysql. 4 digits for the year, 2 digits for the month, and 2 digits for the day. So let's go ahead and execute this query. I actually made a mistake here. So we don't see the result. Instead, we see the action output or the output window. If you scroll to the bottom, you can see the details of the error. So here I used the wrong name for the column. We should separate these two words with an underscore. That is the name of our column. So let's execute the query one more time. So we only have 3 customers born after January 1st, 1990. So these were examples of comparison operators in SQL. In the next tutorial, I'm going to show you how to combine multiple conditions when filtering data. All right, here's your exercise. I want you to write a query to get the orders that are placed this year. So look at the orders table, see what columns do we have there, and based on that, write a query with a where clause. So here's the orders table. In this table, we have this column, order date. We can use this column to see the orders that are placed this year. So here's our query. Select star from orders where order underline date is greater than or equal to January 1st, 2019, assuming this is the current year. So 2019-01-01. Now, since currently we are in the year 2019, this query will return all the orders placed this year. But next year, this query is not going to give us the right result. But don't worry about it. Later in the course, I will show you how to write a query to get the orders placed in the current year. So for the purpose of this exercise, this is a valid solution. Now let's execute this query and see what we get. So we have only one order, order ID 1, that is placed in the current year. In this tutorial, I'm going to show you how to combine multiple search conditions when filtering data. So let's say we want to get all the customers that are born after January 1st, 1990, who also happen to have more than 1,000 points. So this is where we use the AND operator. So we type out AND, and after we type out another condition, like points greater than 1,000. Now when we execute this query, we'll only get customers who have both these conditions. Let's take a look. So execute, we only have 2 customers. And if you look, both these people are born after 1990 and they have more than 1,000 points. So this is the AND operator. When we use this operator, both these conditions should be true. In contrast to the AND operator, we have the OR operator. So with OR, if at least one of these conditions is true, that row will be returned in the result set. Let's take a look. Now we execute this query again. Instead of 2 records, we have quite a few records. So for example, we have this person who is not born after 1990, But if you look at their points, they have more than 1,000 points. So any customer records that satisfies at least one of these conditions will be returned. Now let's take this to the next level. Let's say we want to get customers who are either born after 1990 or they should have at least 1,000 points and live in Virginia. So this is how we do this. We type out and then we add another condition, state equals Virginia. Let's execute this query and see what we get. We only get 4 records. So these are the customers that are born either after 1990 or they have more than 1,000 points and live in Virginia. If you look at the first customer here, this person is not born after 1990, but you can see that she lives in Virginia and she has more than 1,000 points. So the last 2 conditions are true for this customer. Now, when combining multiple logical operators, you need to be aware of the order of these operators. So earlier I talked about the order of arithmetic operators. I told you that multiplication have a higher order than addition and subtraction. And we can use parentheses to override the default order. We have the same concept in logical operators. So the AND operator is always evaluated first. So when this query is executed, the query execution engine first evaluates this condition because here we're using an AND. It doesn't matter that we typed out this condition after the first condition because the AND operator has a higher precedence. Now you can always change the order using parentheses, and this also makes your code cleaner and easier to understand. So here we can put parentheses around these last 2 conditions. And also we can put these on a new line for clarity, something like this. So anyone who reads this code can easily understand what is the intent of this query. Now we also have another logical operator called not, and we use that to negate a condition. Let me show you. So I'm going to simplify our where clause. Let's say we're searching for customers who were born after 1990 or they have more than 1,000 points. If we execute this query, we get these people, customers with ID 1, 3, 5, and so on. Now we can use the not operator to negate this condition. So we apply not here, and preferably we also put parentheses around this condition. Now when we execute this query, we'll see other customers that are not in the current result set. Let's take a look. So instead of customers with IDs 1, 3, 5, 6, and so on, we get the customers with IDs 2, 4, and 10. Now, technically, these customers were born before 1990, and they have less than 1,000 points. So if you look here, this first customer was born before 1990, and he has less than 1,000 points. How did I know that? Let me show you a trick that I learned in math. Whenever you have a not operator, you can simplify your expression like this. We apply the not operator to the first condition. People who were born after 1990. How can we negate this condition? Well, the greater than operator becomes less than or equal to. That is the inverse of that condition, right? Now we apply the not to or to negate the or. What do we get? We get and. Finally, apply the not operator on the last condition, people who have more than 1,000 points. When we negate this condition, we get customers with less than or equal to 1,000 points. Now we can remove the not operator to simplify this. We don't need parentheses anymore because we only have 2 conditions that are combined with an and. Here's the result. As you can see, this is much easier to read and understand. People who were born before this date and they have less than 1,000 points. All right, here's your exercise. From the order items table, get the items for order number 6, where the total price for that item is greater than 30. All right, here's the order items table. In this table, we have these columns: order ID, product ID, quantity, and unit price. If we multiply the quantity by unit price, we can get the total cost of that item. And then we can compare it with 30. So let's go ahead and write this query. Select star from order items, where here we need 2 conditions. One is for the order, so order underline ID should be 6. And the second condition, we want to calculate the total price. So we get the unit price, multiply it by quantity, and this value should be greater than 30. So as we can see, we can use an arithmetic expression in a where clause. It's not limited to the select clause, okay? Now let's execute this query and see what we get. We should get only one item. That is for product 1. Here the quantity is 4 and unit price is just over $8. So the total price for this item is greater than 30. Hey guys, Mosh here. In case you haven't seen my website yet, head over to codewithmosh.com. This is my coding school where you can find plenty of courses on web and mobile application development. In fact, recently I published a complete SQL course that is about 10 hours long, and it teaches you everything you need to know from the basic to the advanced topics such as database design, security, writing complex queries, transactions, events, and much, much more. These are the topics that every software engineer must master. This YouTube course you've been watching is the first 3 hours of my complete SQL course that is about 10 hours long. So if you want to master SQL and get job ready, I highly encourage you to enroll in my complete SQL course. You can watch it anytime, anywhere, as many times as you want. You can watch it online or download the videos. The course comes with a 30-day money-back guarantee and a certificate of completion that you can add to your resume. The price for this course is $149, but the first 200 students can get it for just over $10. So if you're interested, the link is below this video. In this tutorial, I'm going to show you how to use the in operator in SQL. So as an example, let's say we want to get the customers that are located in Virginia or Florida or Georgia. One way to write this query is like this. So where state equals Virginia, or state equals Georgia, or state equals Florida. Now, people who are new to the SQL language or programming in general find this expression a little bit strange. They ask, Mosh, why can't we write this expression like this? Where state equals Virginia, or Georgia, or Florida. Here's the reason. We use the OR operator to combine multiple conditions. So here we have a condition, or an expression more accurately, but on the right side of this OR operator, we have a string. In SQL, we cannot combine a string with a Boolean expression that produces a Boolean value, which can be true or false. So that is why we have to write our query like this. So we have multiple expressions or multiple conditions, and we're combining them using the OR operator, okay? So now if we execute this query, we get these customers here, but there is a shorter and cleaner way to get the same result. Instead of combining multiple conditions using the OR operator, we can use the in operator. So where state is in, and then in parentheses, we add all the values like Virginia, comma, Florida, comma, Georgia. And the order doesn't matter. This query is exactly equivalent to what we had earlier. But as you can see, it's shorter and easier to understand. So let's execute it. Look, we get the exact same result. Now here we can also use the not operator. Let's say we want to get the customers outside of these states. So we can use where state not in this list. Now if we execute this query, we get customers who are located in Colorado, Texas, and so on. So use the in operator when you want to compare an attribute with a list of values. Now here's your exercise. I want you to write a query to get the products where their quantity in stock equals to one of these values, 49, 38, and 72. So pause the video, do this exercise, and then come back, continue watching. All right, this is pretty easy. So we do a select star to get all the columns from the products table where quantity in stock. We use the in operator to compare this attribute with these values, 49, 38, and 72. Let's execute the query. We get only 2 records because we don't have a product with quantity in stock equal to 72. In this tutorial, we're going to look at the between operator in SQL. So let's say we want to get the customers who have more than 1,000 and less than 3,000 points. One way to write this query is like this, where points greater than 1,000, well, more accurately, greater than or equal to 1,000, and points less than or equal to 3,000. When we execute this query, we get how many? We get 4 people that satisfy this criteria. Now, whenever you're comparing an attribute with a range of values, you can use the between operator, and this makes your code shorter and cleaner. So we can rewrite this expression like this, where points between 1,000 and 3,000. This is exactly equivalent to what we had before. So these range values are also inclusive. That means points is going to be greater than or equal to 1,000 or less than or equal to 3,000. Let's execute the query. We get the exact same result. All right, now as an exercise, I want you to write a query to get the customers that are born between January 1st, 1990 and January 1st, 2000. All right, so we start with select star from customers where birth underline date between. So what matters here is that we can use the between operator for date values as well. It's not limited to using numbers. So where birth date between, now we need to supply 2 date values. So as I told you before, the format for dates is 4 digits for the year, so 1990, 2 digits for the month, and 2 digits for the day. So the birthday should be between this value and here's the second value, 2000, 0, 1, and 01. Let's execute this query. We get only 3 people who match this criteria. In this tutorial, I'm going to show you how to retrieve rows that match a specific string pattern. For example, let's say we only want to get the customers whose last name start with B. So here in the where clause, we type out where last name. This is where we use the like operator. And right after that, we add a string pattern. So we want to get the customers whose last name start with B, and we have any number of characters after B. So we use the % sign to indicate any number of characters. We might have 1 character after B, or no characters, or 10 characters. With this pattern, we get all the customers whose last name start with B. And also, it doesn't matter if it's an uppercase or a lowercase b. So let's execute this query. There you go. So we only have 3 customers whose last names start with B. As another example, let's say we only want to get the customers whose last names start with brush. So we change our pattern to brush %. Now let's execute the query. We only get this 1 customer here. Now this % sign doesn't have to be at the end of the pattern. It can be anywhere. For example, let's say we want to search for customers who have a B in their last name, whether it's at the beginning, in the middle, or at the end. So we change our pattern to %B %. This pattern means we can have any number of characters before or after B. Let's execute the query. These are the customers who have a B somewhere in their last name. It doesn't matter if B is at the beginning or in the middle or at the end. Let's look at another example. I want to get all the customers whose last name end with Y. So here's the pattern we use. Let's execute this query, and we have 5 customers whose last name ends with a Y. So this is how we use the % sign. Now we also have an underscore, and that matches a single character. So with this pattern, we get customers whose last name is exactly 2 characters long. We don't care what the first character is, but the second character should be Y. Let's execute this query. Obviously, we don't have any customers whose last name matches this pattern. But if we change this pattern to 5 underscores, so 1, 2, 3, 4, 5, followed by a Y, we should get these customers. So their last name is exactly 6 characters. We don't care about the first 5 characters, but all of them end with a Y. Now, as another example, we can replace the first underscore with B. And that means we want to get the customers whose last name start with B. And after B, we have exactly 4 characters followed by a Y. Let's execute this query. So we only have one customer that matches this pattern. So this is how we use the like operator. We use the percent sign to represent any number of characters and an underscore to represent a single character. Now, this like operator in Mysql is an older operator, but we also have a newer one that is more powerful, and it allows us to search for any string patterns. And that's what I'm going to show you next. All right, here I'm going to give you 2 exercises for the like operator. First, I want you to get the customers whose addresses contain trail or avenue. And next, I want you to get the customers whose phone numbers end with 9. All right, let's get started with the first exercise. So select star from customers where address like. Now here we want to use a search pattern like this. We want to have trail, but trail can be anywhere in the address. So we put a percent before and after trail. Next, we should use the OR operator to search for another pattern. Or address like. Let me put this on a new line. That is better. Address like, once again, percent, avenue, percent. That's it. So let's execute this query. Here is the result. You should get the customers with IDs 2, 9, and 10. If you look at their addresses, all of them have either trail or avenue in their address. Now let's work on the second exercise. We want to get the customers whose phone numbers end with 9. That is pretty easy. So let me change our where clause. Where phone, once again, we use the like operator, add a percent, followed by a 9. That's all you had to do. Let's execute the query. So here's the result. Customers with IDs 3 and 7. Their phone numbers end with 9. So this is how we use the like operator. And by the way, you can always use the not operator here. Let's say if you want to get the customers whose phone numbers don't end with 9. So we simply prefix like with not. Now, if we execute this query one more time, we get all the other customers in the database. In the last tutorial, you learned about the like operator in SQL. So as another example, let's say we want to search for the customers who have the word filled in their last name. So we type out a where clause like this, where last name like percent filled percent. So the word filled can be anywhere in the last name. Let's execute this query. We get only one customer. Beautiful. Now we also have another operator in Mysql that is regexp, which is short for regular expression. And regular expressions are extremely powerful when it comes to searching for strings. So they allow us to search for more complex patterns. Here's an example. If I want to rewrite this last where clause using a regular expression, it looks like this. Where last name, regexp. Now here in our string pattern, we don't have to type out the percent signs. We only type out filled. So what we have on line 4 is exactly identical to what we have on line 3. Let's execute this query. We get the same result. Beautiful. Now here in regular expressions, we have additional characters that we don't have when we use the like operator. For example, we can use the caret sign to indicate the beginning of a string. So if I put a caret just before the word filled, that means our last name must start with filled. Obviously, if we execute this query, we don't get anyone that matches this criteria. So we use the caret sign to represent the beginning of a string. We also have a $sign to represent the end of a string. So this pattern means the last name must end with filled. Let's execute this query. We get the same result as before. Now we can also search for multiple words here. For example, let's say we want to find the customers who have the words filled or Mac in their last name. So we use a pipe, a vertical bar, and type out another pattern. Let's execute this query. So here we have two customers. One of them has the word Mac. The other has the word field in their last name. Now we can take this to the next level. Let's say we want to find the customers who have the words field or Mac or Rose in their last name. Let's execute the query. We get 3 customers. Beautiful. So we use a pipe or a vertical bar to represent multiple search patterns. Now, as another example, we can change our first search pattern to something like this. Now this pattern means the last name should either start with the word field, or it should have the word Mac in it, or it should have the word Rose. Let's execute the query. Now we get only 2 customers because our customer with the last name Brushfield doesn't match this pattern. However, if we change our first pattern to field $, and execute the query, we get 3 people here, 3 customers. So this is how we can combine multiple special characters when building a complex pattern. Now let's look at another example. Let's say we want to search for customers who have an E in their last name. So these are all the people, all right? Now let's say we want to make sure that before the letter E, we should either have a G or an I. So this is where we use square brackets. And inside the brackets, we add multiple characters like G, I, M, and that matches any customers who have GE or IE or ME in their last name. So any of these characters can come before E. Now let's execute this query. There you go. We only get 2 customers. In the first example, before E, we have I, which is one of the characters inside the brackets. In the second example, before E, we have a G, which is also another valid character before E. Now, once again, the square brackets don't have to be before E. We could add them after E. So any customers who have E followed by an F or an M or a Q in their last name can be returned with this pattern. Obviously, we don't have anyone in the database. So this is how we use square brackets. Now we can also supply a range of characters. For example, we can have E, and just before E, we want to have any characters from A to H. We don't have to type them out explicitly like A, B, C, D, E, F, G. That's very verbose. So we can type out A to H. And now if we execute this query, we get these 3 people. So let's quickly recap everything you learned about regular expressions in this tutorial. We use a caret to represent the beginning of a string. So beginning. We use a $sign to represent the end of a string. We use a vertical bar or a pipe to represent a logical OR. So we can supply multiple search patterns. We use square brackets to match any single characters listed in the brackets. And finally, we use square brackets with a hyphen to represent a range. So any characters from A to, let's say, F. Now, technically, Mysql supports more special characters, but quite honestly, the ones that I have listed in this tutorial are the ones that you'll be using 90% of the time. So just memorize these and you're good to go. Quite honestly, a lot of beginners find the syntax for regular expressions confusing. So in this video, I'm going to give you 4 exercises that I have carefully designed to help you quickly learn about this syntax. Here's the first exercise. Get the customers whose first names are Elka or Amber. And note that this is Amber with a U. Now for the second exercise, return the customers whose last names end with EY or ON. Here's the third exercise. Get the customers whose last names start with my or it contains SE. And finally, as the last exercise, return the customers whose last names contain B followed by R or U. So go ahead and spend 2 to 3 minutes on this exercise. When you're done, come back, continue watching. All right, let's knock out the first exercise. So we want to get all, oops, there's a C here. Select star from customers where first name, regular expression. And here's our pattern. We want to search for 2 words, either Elka or Amber. Simple as that. Let's execute this query. We should get 2 customers. There you go. Amber, and Elka. All right. Now let's knock out the second exercise. So I'm going to delete this. We don't need it anymore. So we want to get the customers. Select start from customers, where last name should end with either EY or ON. So in the search pattern, we type out EY followed by a $sign to indicate the end of a string. Then we add a vertical bar to supply the second search pattern. So ON and once again a $sign. Let's execute this query. Oops, actually I forgot to type out regular expression. There you go. So let's execute this query. And we should get these 4 customers with IDs 1, 3, 5, and 7. The first 3, their last names end with EY. And the last customer, his or her last name ends with ON. All right. Now let's work on the third exercise. So I'm just going to change the regular expression here. We want to get the customers whose last name starts with my or contains SE. So we use a caret to indicate the beginning of a string. So it should start with my, or it should contain SE. Again, very easy. Let's execute this query. And we get the customers with IDs 4, 8, and 10. And finally, we want to get the customers whose last names contain B. So let's change the search pattern. We should have a B followed by R or U. Now, there are 2 ways to write this regular expression. We can use square brackets. So we have B followed by R or U. That's one way. The other way is to use a vertical bar. So BR or BU. These are both valid solutions. So I hope you knocked out these exercises. In the next tutorial, I'm going to show you how to get the records with missing values. In this tutorial, I'm going to show you how to look for records that miss an attribute. For example, if we select all the customers in our database, you can see that the customer with ID 5 doesn't have a phone number. So if you look closely here, you can see the value null. Null means the absence of a value. Now let's say we want to search for all the customers who don't have a phone. Perhaps we want to send them an email and say, hey, your phone is missing in our system. So how can we get these customers? That is very easy. We use the isNull operator. So in the where clause, we type out where phone is null. Now let's execute this query. We only get one customer who doesn't have a phone. Now here we can also use the not operator to get the customers who do have a phone. So we change the condition to is not null. Let's execute the query. Now in the query results, every customer does have a phone number. For this exercise, I want you to write a query to get the orders that are not shipped yet. This is a very useful query that is used in a lot of real applications. For example, let's say you're an admin for an online shop. You want to see the orders that are not shipped yet so you can follow them up. So write a query to get these orders. So here we have the orders table. Let's have a quick look at the data in this table. All right. So if you pay close attention, you see some of these orders don't have a shipped date. And these orders also don't have a shipper ID, which is a unique number for identifying the shippers. So any order that misses a value for the ship date or shipper ID is considered an order that is not shipped. So let's go ahead and write a query to get these orders. So back to our query editor, select star from orders where shipped underline date is null. You could also write shipper ID is null. They're both equally correct. So let's execute this query and we should get 5 orders. Orders 1, 3, 4, 6, and 8. In this tutorial, I'm going to show you how to sort data in your SQL queries. So here we have a query to select all the customers from the customers table. If you look at the query result, you can see that our customers are sorted by their ID. So we have customers 1, 2, 3, 4, and so on. This is the default sort column, but we can always change this using the order by clause. But first, let me explain why the customer ID column is the default sort column. So first, I'm going to open up the navigator panel. On the left side, here's the customers table. Now let's click on this middle icon here that looks like a tool. This opens up our customers table in the design mode. So here we can change our columns. We can add new columns or remove existing ones or change their name or order and so on. Now, if you pay close attention, you can see a yellow key just before customer ID. This means that this column is the primary key column for this table. So in relational databases, every table should have a primary key column, and the values in that column should uniquely identify the records in that table. So back to our query window, you can see that the values in this column uniquely identify each customer. So the customer ID column is the primary key column in this table, and that is why when we write a query against this table, our customers are sorted by their ID by default. Now, let me show you how to sort customers by a different column. So here in the order by clause, we type out the name of another column, like first name. Let's execute the query. Now you can see our customers are no longer sorted by their ID. Instead, they're sorted by their first name in ascending order. Now, if you want to reverse the sort order, simply type out DESC, which is short for descending. Now, we are sorting these customers in descending order. Okay, we can also sort data by multiple columns. For example, let's say first we want to sort our customers based on their state, and then within each state, we want to sort them by their first name. So we type out multiple columns here, state and first name. Let's execute the query. Now you can see that the first state we have here is California, followed by Colorado. And now here in Florida, we have two customers, and these customers are sorted by their first name. Let's have a close look here. So first we have Amber, and then we have this other customer here. Now we can also use the descending argument anywhere here. For example, we can sort these customers by their state in descending order, and then sort them by their first name in ascending order, or once again, in descending order. So there are various ways we can sort data. Now, one of the differences between MySQL and other database management systems is that in MySQL, we can sort data by any columns, whether that column is in the select clause or not. For example, let's say we only want to select the first and last name for each customer. Now we can sort the result by any columns in this table. They don't have to be first name and last name. For example, we can sort them by their birth date. Take a look. So this is a valid query in MySQL, but other database management systems sometimes yell at you when you write a query like this. Now we can also sort data by an alias. For example, here in our select clause, let's add the number 10 and give it an alias as, let's say, points. So points is not a valid column in this table. It's simply an alias for an expression. In this case, a simple number. Now here we could have a complex mathematical expression. It doesn't really matter. We can still sort data by an alias. So we can order by points and then first name. Once again, this is a valid query from MySQL's point of view. Now, one last thing before we finish this tutorial. I've seen some tutorials that teach you how to sort data by column positions. For example, here we can order by 1 and 2, and that basically means sort the data by the first name and then the last name. So these are the order of these columns. If we execute this query, you can see that our customers are sorted by their first name and then the last name. While this approach works, it's something that you should avoid, because if in the future you come back here and add a new column in front of the first name column, let's say birth date. Now our customers are no longer sorted in the previous order. So sorting data by column positions produces unexpected results, and it's something that you should avoid. Instead, always sort by column names, like first name. All right, here's your exercise for this tutorial. In this database, we have this table called order items, where we can find the items for each order. Now, I've written a query that you cannot see here because that's the solution to the exercise I'm going to give you. That query produces this result. So we only have the items for the order with ID 2, and we have sorted these items based on the total price for each item. So the total price for each item equals quantity times unit price. In this case, the total price for product 1 is just over $18. So go ahead and write a query to select all the items for order with ID 2 and sort them by their total price in descending order. All right, let's select everything from order items where order ID equals 2. That returns all the items for this order. Now we want to make sure to sort them by their total price. So here in order by clause, we write an expression, quantity times unit price. This returns the total price for each item. And then we add the descending argument here. So once again, the expression that we use in the order by clause doesn't have to be a column name. It can be an alias or an arithmetic expression like this. Let's go ahead and execute this query. This is what we get. Now for clarity, I would like to add another column in the result. So let's say quantity times unit underline price. We give it an alias like total price. Let's execute the query. We can clearly see that this data is sorted by the total price in descending order. However, there is a bit of duplication in our query. We have repeated this expression in 2 places. So now we can simplify our order by clause by using an alias, that is total price. And we get the exact same result. Next, I'm going to show you how to limit the number of records returned from your queries. In this tutorial, I'm going to show you how to limit the number of records returned from your query. For example, when we execute this query, we get all the customers in the customer table. So we have 10 customers here. Now, what if we only want to get the first 3 customers? That's where we use the limit clause. Let me show you. So after from, we type out limit 3, and this will return only the first 3 customers. Now, if the argument that we pass here is greater than the number of records that our query produces, we'll get all the records in the query result. For example, if I pass 300 here, obviously we don't have 300 customers in this table. So when we execute this query, we'll get all the 10 customers in this table. So this is how the limit clause works. Now here we can optionally supply an offset, and this is very useful in situations where we want to paginate the data. For example, let's say we have a website, and on this website, we have a web page for the user to see all the customers in the database. Now, for simplicity, let's imagine we want to show only 3 customers per page. So what are the customers that we're going to have on page 1? We're going to have customers 1, 2, 3. On page 2, we're going to have customers 4, 5, 6. And on page 3, we're going to have customers 7, 8, 9. Now, let's say we want to write a query to retrieve the customers on page 3. How can we do that? Well, we want to skip the first 6 records and then pick 3 records, right? So we change our limit clause to something like this. Limit 6 and 3. So 6 is what we call an offset, and that basically tells Mysql to skip the first 6 records and then pick 3 records. Let's execute this query. All right, now we get customers 7, 8, and 9. Now, for your exercise, I want you to get the top 3 loyal customers. These are the customers that have more points than everyone else. All right, first we select everything from the customers table. Now we need to order these customers by their points in descending order. So if you look at the query result, you can see that customers are sorted by their loyalty. So the most loyal customers come first. Now we want to pick only the first 3 customers. And that's where we use the limit clause. So limit 3. Let's execute this query. And these are the most loyal customers, customers with IDs 5, 6, and 3. Now, here's one thing I want you to remember, and that is the order of the limit clause. The limit clause should always come at the end. So first we have the select clause, then we have from. Optionally, we can have where, followed by order by, and finally limit. The order of these clauses matters. If you change the order, MySQL is going to yell at you. So pay attention to the order when writing your queries. So far, we have only selected columns from a single table. But in the real world, we quite often select columns from multiple tables. And that's what I'm going to show you over the next few tutorials. So on the left side, if you look at our orders table, let's select all the data here. In this table, we're using the customer ID column to identify the customer that has placed each order. Now, as I told you before, we don't store customers' information here, like their phone number, their email, their address, because this information can change in the future. And if a given customer has placed multiple orders, then we'll have to come back and change multiple records. We don't want to do that. That's why we have separate tables for customers and orders. Now, in this tutorial, I'm going to show you how to select the orders in the orders table, but instead of showing the customer ID, show the full name for each customer. So let's go back to our query window. All right, so we want to select everything from the orders table. Now we should combine the columns in this table with the columns in the customers table. That is where we use the join keyword. Now here we can optionally type inner join, because in SQL we have two types of join, inner join and outer join. We'll look at outer joins later in this section. So for now, we're only using an inner join, and this inner keyword is actually optional, so we don't have to type it. So we want to join the orders table with the customers table. Now, on what basis do we want to join these tables? Well, here in the customers table, we have this customer ID column. So if we put these two tables next to each other, we want to line up the records such that the customer IDs are equal. That is where we use the on phrase. So after on, we type out a condition. Here's the condition we need to type out. Orders.customer_ID should be equal to customers.customer ID. Now, this is getting outside of the screen, so let me break up this line. That's better. So with this query, we're telling MySQL that, hey, whenever you're joining the orders table with the customers table, make sure that the customer ID column in the orders table equals the customer ID column in the customers table. Now let's execute this query. Look at the result. Since we're selecting everything here, the first few columns are from the orders table because we have listed that first. Now, after all the columns in the orders table, we have the columns in the customer table. So customer ID, first name, last name, and so on. Now let's simplify the result set and select only order ID, first name, and last name. So back to our query, we select order ID, first name, and last name. Now let's execute the query. That is better. So next to each order ID, we can see the name of the customer that placed that order. Now, what if we want to display the customer ID here as well? Well, let's put that here and see what happens. Customer ID. Execute the query, we get an error. So if you look at the output window, down the bottom, you should see an error saying column customer ID in the field list is ambiguous. Now, unfortunately, I cannot show you this error because the size of my recording window is smaller than MySQL Workbench. But that aside, let me explain why we're getting this error. Because we have this customer ID column in both the orders and customers tables. So MySQL is not sure which table do we want to select this column from. That is why it's saying this column is ambiguous. So we need to qualify this column by prefixing it with a table name. We can either pick it from the orders table or the customers table. It doesn't really matter because the values are equal, right? So in situations where you have the same column in multiple tables, you need to qualify them by prefixing them with the name of their table, okay? Now let's execute the query one more time. So there you go. We have order ID, customer ID, and the full name. Beautiful. Now, one more thing before we finish this tutorial. If you pay close attention, we have repeated the word orders in multiple places. We have it here, as well as in the join condition. The same is true about the customers table. We have repeated that here. We can get rid of this repetition and make our code simpler by using an alias. So right after each table, we can give it an alias, O as in short for orders. So by convention, we abbreviate the table's name. Now, wherever we have orders, we should replace that with O. So here in the join condition, we replace orders with O, and also one more time in the select clause. There you go. We can also apply an alias for the customer's table. We call it C, and then we simplify our join condition like this. So this is how we can join columns from multiple tables. Now, for your exercise, I want you to look at the order items table. So in this table, we have these columns: order ID, product ID, quantity, and unit price. Now, I want you to write a query and join this table with the products table. So for each order, return both the product ID as well as its name, followed by the quantity and the unit price from the order items table. And by the way, make sure to use an alias to simplify your code. All right, first, let's select everything from the order items table and then join it with the products table. How are we going to join these tables? On order underline items dot, well, actually, let's just give this an alias right away. So we use OI as an abbreviation for order items and P as in short for products. So OI dot product ID should be equal to P or products dot product ID. And by the way, remember that when you give an alias to a table, you have to use that alias everywhere else. So here I cannot type out products. Mysql is going to yell at me. So let's use the abbreviation. All right, this is how we join these tables. Let's execute this query up to this point. All right, so we see all the items from the order items table, followed by the columns from the products table. Now, we want to explicitly select a few columns here. So from the order items table, we want to select order underline ID. Well, technically, we don't have to prefix this with the table name because this column is not repeated in multiple places. So it's not ambiguous. So let's make the code shorter. That's better. Now we want to select the product ID column. But because this column exists in both tables, we have to prefix it with a table name, either OI or P. It doesn't really matter. Next, we want to select quantity and finally unit price. Now, actually here we have this unit price column in both tables. So this is the unit price in order items table, and this is the unit price in the products table. Now, you might be curious why we have this column in two places. The reason for this is that the price of products can change. So for each order item, we want to have the price at the time the user or the customer placed the order. So this is a snapshot of the price at a given point in time. The unit price that we have in the products table is the current price right now. This is very important for reporting, otherwise we cannot calculate the sales properly. So because we have the unit price column in two places, in this case, we should pick it from the order items table because this is the price at the time of placing the order. Now let's execute the query. So here's the final result. In the real world, when you work as a developer or a database administrator, quite often you will have to work with multiple databases. In this tutorial, I'm going to show you how to combine columns from tables across multiple databases. That's pretty easy. So in the SQL Store database, we have these tables that you're fairly familiar with. Now imagine this products table was not here. Now, if you look at the SQL inventory database, you can see here we have another products table. This products table is exactly the same as the products table that we have in the SQL Store database. So it has the same columns and the same data. Now, technically, this is not a good design. You don't want to have the same table repeated in multiple places. But for this demo, let's just imagine that we don't have the products table here. So we want to join the order items table with the products table in the SQL inventory database. Let's get started. So select everything from the order items table. Let's give it an alias straight away. We want to join this with the products table. This products table is part of the SQL inventory database. So we'll have to prefix this with the name of its database. So we type out SQL inventory dot. Now, once again, we can give this an alias like P, then type out our join condition. So OI dot product ID should be the same as P dot product ID. Let's run the query. There you go. So we successfully joined tables across multiple databases. Now, note that we're prefixing the products table with the name of its database because the current database that we're writing this query against is the SQL Store database. Take a look. In the Navigator panel, the SQL Store database is displayed in bold because earlier we wrote the use statement to select a database. That was SQL Store. Now, what if we select the SQL inventory database? Let's see what happens. So SQL inventory. Now, because we have multiple statements, we have to terminate this with a semicolon. Now, we want to select everything from the order items table, but we don't have this table inside of this database. So now we'll have to prefix this table with the name of its database. That is SQL _store. Let's execute the query. Okay, everything works beautifully. So here's the lesson. You only have to prefix the tables that are not part of the current database. In other words, your query will be different depending on the current database. In SQL, we can also join a table with itself. Let me show you an example. Take a look at this database, SQL HR. In this database, we have these two tables, employees and offices. Let's take a look at the data in the employees table. There you go. So here we have these columns, employee ID, first name, last name, their job title, salary, and reports to. This is the ID of the manager for this person or this employee. Now, once again, we don't want to repeat the manager's information here, like their phone number, their address, because this information can change in the future. So we are only using their identifier or their ID to refer to them in this table. Now, where can we find the information about this manager? Well, this manager is actually an employee of the same organization. So look at this example. The manager ID is 37270. Now, if you look on the left side, here's the ID of that manager, which is another employee. Now, who's the manager for this employee? Let's take a look. We don't have any values here, so the value for this cell is null. So this employee doesn't have a manager, and that means they are the CEO. So now let's go ahead and write a query to join this table with itself so we can select the name of each employee and their manager. Back to our query window. First, we need to select the SQL HR database. Next, we select everything from the employees table. We give it an alias like E. Now we need to join this table with itself. So once again, we type out employees, but we need a different alias. What should we call this alias? Well, we want to join this table with itself so we can find the managers, right? So we can use M as in short for managers. Now let's type out our join condition. So from the employees table, we need to join the reports _2 column to the managers table, which is basically the employees table itself. And what column? That is employee _ID. Now let's execute this query and see what we get. So we see all the columns from the employees table repeated. The first set of columns represent information about the employees. And then after that, we have information about the manager. In this case, we have only one manager in this table. But with this technique, we can easily create an organization chart. We can have a hierarchy of managers. Now let's simplify our query and select only the name of the employee and their manager. So back here, since every column in the employees table is repeated twice, we need to prefix each column with a table name. For example, from the employees table, you want to get employee ID as well as the first name. And then from the managers table, you want to select the first name as well. So every column should be prefixed with the table name, or more accurately, the alias, because all these columns exist in two tables, right? Let's go ahead and execute this query. So this is what we get: employee ID, first name, And here's the manager's first name. We can improve this query by giving an alias to this column because it doesn't make sense to have two first name columns. So let's give an alias to the third column, manager. Now let's execute it one more time. And here's the end result. So we have the employee ID, first name, and manager. So joining a table with itself is pretty much the same as joining a table with another table. The only difference is that we have to use different aliases and we have to prefix each column with an alias. This is what we call a self-join. Next, I'm going to show you how to join more than two tables. In this tutorial, I'm going to show you how to join more than two tables when writing a query. For example, back to our SQL Store database, look at the orders table. Now you know how to write a query to join this table with the customers table to return information about the customer who placed each order. But here we also have another column, status, which is similar to the customer ID column. So the name of the statuses are not stored in this table. They're somewhere else in the order statuses table. Let's have a quick look here. So our orders can be either processed, shipped, or delivered. And these are the identifiers for each of these statuses. Now back to our orders table, in the status column, we store the order status ID. So now we should write a query to join the orders table with two tables, the customers table and order statuses table. The result of this query is going to look like this. So for each order, we see the order ID, the date, the first and last name of the customer, and finally the status of the order. This is a beautiful report we can create for our users. So let me show you how to write this query. Back to our query editor, first we need to select the SQL Store database. Now we need to select everything from the orders table. Let's give it an alias. Next, we need to join this with the customers table. On o.customer ID should be equal to c.customer ID. Nothing new so far, exactly like before. Now here we can write another join keyword to join the orders table with order statuses table. So we type out order statuses, and also we give it an alias like OS. What is our join condition? Well, back in the orders table, here we have this status column. So the value in this column should be equal to the order status ID column in order statuses table, right? So back to the query. So orders table dot status should be equal to order statuses dot order status ID. Make sure to get the name right. Don't have a typo. Otherwise, you're going to get an error. So this is how we can join three tables. Now, in the real world, as you work on more complex problems, you may end up joining even 10 tables. So this is not uncommon in the SQL world. Now let's go ahead and execute this query. First, we get the columns from the orders table, followed by the columns from the customers table, and so on. This result is so complex and hard to extract information from. So let's explicitly select a few columns here. From the orders table, we want to select the order ID column, as well as the order date. Then from the customers table, we want to select the first name and the last name. And finally, from the order statuses table, we want to select the name column. Now we can give this an alias like status. That's better. Let's execute the query one more time. So here's the end result. We have order ID, order date, the name of the customer, followed by the status of the order. All right, for your exercise, take a look at this SQL invoicing database. Here we have this table, payments, and these are the payments that each client has made towards a given invoice. Let's take a look at the data. So we have these columns, like client ID, that identifies the client. So we can join this table with the client's table to see the name of the clients. Next, we have invoice ID. We also have date, amount, and payment method. So similarly, we can join this table with the payment methods table here. Let's have a look at the data in this table. These are the payment methods: credit card, cash, PayPal, and wire transfer. So back to the payments table, I want you to write a query and join this table with the payment methods table as well as the clients table. Produce a report that shows the payments with more details such as the name of the client and the payment method. All right, first we need to use the SQL invoicing database. Now we can select everything from the payments table, which we call P. Next, we need to join this with the clients table, which we call C. On P.clientID should be equal to C.clientID. Let me double check the column name to make sure I got it right. So back to the payments table, the column is called client ID. We also have a column called payment method that we should join to the payment method ID column of the payment methods table. So back to the query. Once again, we use a join statement here. Join with payment methods. We give it an alias PM on p.payment underline method should be equal to pm.payment method ID. Make sure to type it out correctly, otherwise you're going to get an error. So let's go ahead and execute the query up to this point. There you go. Finally, let's handpick the columns that make the most sense. So from the payments table, let's select the date, followed by invoice ID. What else do we have here? So we have client ID, invoice ID, date, amount, and payment method. I'm going to pick the amount column from here as well. So back to the query, p.amount. Now we need to add information about the client. Let's take a look at this table, clients. So here we have columns like name, address, city, and so on. All we need here is the name column. So back to the query. From the clients table, let's select the name column. And finally, from the payment method table, let's select, what is that column called? It's called name. So back to the query, pm.name. So here's the end result. Now we can put these columns in any order that we want. It doesn't really matter. Let's execute the query and make sure everything works. So on this date, for this invoice, we have a payment for this amount by this client using a credit card. In all the examples you have seen so far, we use a single column to uniquely identify the rows in a given table. For example, in the customers table, we have this customer ID column, which uniquely identifies the rows in this table. But there are times that we cannot use a single column to uniquely identify records in a given table. For example, look at the order items table. In this table, we have columns like order ID, product ID, and so on. Now, if you look at the data, you can see that the values in the order ID column are repeated. They're duplicated. We have 222, 66, and so on. So we cannot use this column on its own to uniquely identify each record. The same is true for the product ID. The values in this column are also duplicated. So in this table, we use the combination of the values in both these columns to uniquely identify each order item. As an example, in this order, we have 3 items for products 1, 4, and 6. And for each product, we have the quantity and unit price. So if we use the combination of the values in both these columns, we can uniquely identify each order item. In other words, we don't have 2 records for order ID 2 and product ID 1. We only have a single record for that item, right? Now let's open this table in the design mode. So over here, click on this middle icon that looks like a tool. Note that this yellow key that represents the primary key exists on both these columns. This is what we call a composite primary key. A composite primary key contains more than one column. Now, why does this matter? Well, when you have a table with a composite primary key, you need to learn how to join that table with other tables. For example, here we have this table order item notes that we use to keep notes for each order item. Let's take a look at the data here. So we have this column note ID, which uniquely identifies the records in this table. Next to that, we have order ID and product ID. You learn that the combination of these 2 columns uniquely represents an order item. So here for order number 2, for product number 1, we have 2 notes. Now let me show you how to join this table with the order items table. So back to our query, You can see that I've already selected the SQL stored database, so I'm not going to type out a use statement. All right, let's select everything from the order items table, give it an alias. Now we need to join this with order item nodes. Also, we give it an alias. How are we going to join these tables? Based on two columns. Back to the order items table. These are the columns that we need to use in our join condition. So in the order items table, we have this order ID column. This should be equal to the same column in order item nodes table. So OIN dot order ID. But this is not enough. We should also join these tables based on the product ID column. So we type out and then we type out our second condition. So order items dot product ID should be equal to order item nodes dot product ID. This is what we call a compound join condition. So we have multiple conditions to join these two tables. In this tutorial, I'm going to talk about the implicit join syntax in MySQL. So here we have a basic inner join. We're selecting everything from the orders table, joining it with customers table on orders.customer_id equal to customers.customer_id. Pretty basic. There is another way to write this query using implicit join syntax. Let me show you how that works. So we select everything from. Now here we can type out multiple table names. So orders, comma, customers. And we can also give them an alias. So C and O. And then we move this join condition to the where clause. So I'm going to copy this from here, type out a where clause, and paste the condition. These two queries are equivalent. What we have here is called implicit join syntax. Now, even though MySQL supports this syntax, it's something that I suggest you not to use, because if you accidentally forget to type out the where clause, you will get a cross join. Let me show you what I mean. So first, I'm going to delete the first query and execute this. So we get 10 records because we have 10 orders in this database. So far, so good. But what happens if we accidentally forget to type out the where clause? Instead of 10 records, we're going to get probably 100 records, because every record in the order table is now joined with every record in the customers table. This is what we call a cross join. Now, later in this section, I'm going to talk about cross joins in more detail. But what I want to point out in this tutorial is that it's better to use the explicit join syntax. So we use join because this syntax forces you to type out the join condition. If you simply join orders with customers without typing the join condition, you're going to get a syntax error. So to recap, be aware of the implicit join syntax, but write all your joins using the explicit syntax. Earlier in this section, I told you that in SQL, we have two types of joins, inner joins and outer joins. Now, so far, you have only seen examples of inner joins. And I also told you that this inner keyword is optional. So whenever you type out a join, you're using an inner join. In this tutorial, we're going to look at outer joins and the problems they solve. So let's start by writing a query that uses an inner join, and then we'll convert that inner join to an outer join. So select everything from the customers table, join it with the orders table on c.customer_id should be equal to o.customer_id. Pretty basic, right? Now for clarity, let's pick a few columns from these two tables. So from the customers table, I want to pick customer ID and first name. And from the orders table, I want to pick order ID. Now, finally, let's sort the result so we can clearly see what we get. So order by c.customer_id. Let's execute this query and see what we get. So here's the result. For customer number 2, called Ines or Ines, whatever, we have two orders, order 4 and order 7. Similarly, for customer number 5, we have 2 orders and so on. Now, there is something missing in this result. We only see customers who have an order in our system. These are customers 2, 5, 6, 7, 8, and 10. But if you look at the customers table, you can see that we have other customers like customer number 1, customer number 3, and so on. Now, currently, we don't have any orders for these customers, and that's the reason we don't see them in this result set. But what if you want to see all the customers, whether they have an order or not? That's when we use an outer join. Let me show you how that works. So back to our query. The reason we only saw customers who have an order was because of this join condition. When joining these two tables, we are only returning records that match this condition. So for a given customer, if we do have an order, that record is returned. But as you saw a second ago, some of our customers don't have an order. So for those customers, this condition is not valid. And that is the reason they're not returned in the result set. To solve this problem, we use an outer join. Now in SQL, we have two types of outer joins. We have left joins and right joins. When we use a left join, all the records from the left table, in this case, customers, are returned whether this condition is true or not. So we get all the customers, and if they do have an order, we'll see the order ID as well. Let's execute this query and see what we get. So there you go. Customer number 1 doesn't have an order, and that's why we get null in this cell. Customer number 2 has 2 orders, 4 and 7. Customer number 3 also doesn't have an order, so we have null for order ID. This is the result of a left join. So back to our query, when we use a left join, all the records from the left table are returned whether this condition is true or not. Now, what if we use a right join? In this case, all the records from the orders table are returned whether this condition is true or not. Let's execute this query and see what we get. So we get the same result as before when we use an inner join, because we are selecting all the records from the right table, which is the orders table. So we don't see all the customers, we see all the orders, right? Now, if you want to use a right join and still see all the customers, you need to swap the order of these tables. So we put the orders table first. That's going to be our left table. And then we put the customers on the right side. So now with this query, we'll return all the records from the right table, which is the customers table. When we execute this, we get all the customers, whether they have an order or not. Beautiful. Now, one last thing before we finish this tutorial. I've seen developers use the outer keyword here. So either right outer join or left outer join. But technically, the outer keyword is optional, just like the inner keyword. So you don't have to type it out. So I'm going to remove this to make my code shorter and easier to understand. So to recap, if you use the join keyword, you're doing an inner join. And if you do a left or right join, you're doing an outer join. Here's your exercise for this tutorial. I want you to write a query that produces this result. So we have 3 columns here: product ID, name, and quantity that I picked from the order items table. So here we need to join the products table with order items table, so we can see how many times each product is ordered. However, if we do an inner join, we'll only see the products that have been ordered. But here I'm doing an outer join. So product number 7 has never been ordered, but it still exists in the result. We see null for the quantity. So go ahead and write an outer join to produce this result. All right, first we select everything from the products table and then do a left join with the order items table. Our join condition is p.productID equals oi.productID. So because we're using a left join, we'll get all the products in the products table, whether this condition is true or not. If they have never been ordered, we'll still see them in the result. Now, let's pick a few columns for clarity. So p.productID, p.name, and oi.quantity. That's it. Let's execute the query. We get the same result as before. So all the products are here, and product number 7 has never been ordered, so we see null for the quantity. Similar to inner joins, we can use outer joins between multiple tables. Let me show you. So here's the query that we wrote in the last tutorial. We're doing a left join between customers and orders tables. So when we execute this query, we get all the customers, whether they have an order or not. If they have an order, we see the order ID. Beautiful. Now, if you look at the orders table, you can see that some of our orders have a shipper ID. These are the orders that have been shipped. So now let's join the orders table with the shippers table to display the name of the shipper in the result. So back to our query. After this left join, let's write another join. Here I'm doing an inner join. So let's inner join the orders table with the shippers table. Join shippers. We call it SH. On, what is the join condition? Well, O.shipper ID should be equal to sh.shipper ID. All right. So in this query, we have a left outer join and an inner join. Let's see what we get. All right. We only see 5 records, but we have more orders. So here we have the same problem we had before. Some of our orders don't have a shipper, and that is why they are not returned here. In other words, this join condition is not true for some of our orders. So back to the orders table. As an example, this first order doesn't have a shipper. Shipper ID is null, and that is why it's not returned in the query result. So to solve this problem, we should use a left join. We want to make sure that all orders are returned, whether they have a shipper or not. So back to the query, we need to replace this inner join with a left join. So let's execute the query and see what happens. Now we should have quite a few more orders. There you go. Now to make this example more interesting, I'm going to add the shipper name here. So back to our select clause, let's add a new column. So shipper.name. And we can give it an alias like shipper. Let's execute the query and here's the result. So we get all the customers, whether they have an order or not. And for those who do have an order, we get all the orders, whether they have a shipper or not. This is the power of outer joins. Now, in the last tutorial, you learned that you can get the same result with both a left join or a right join. You just have to swap the order of the tables. However, as a best practice, avoid using right joins, because when you're joining multiple tables and you have left and right and inner join, things get really complex. Someone else reading your code will have difficulty visualizing how you're joining these tables. As an example, if you had a right join here and then a left join after, it would be harder to visualize how these tables are getting joined. So as a best practice, avoid right joins and use left joins instead. And here's your exercise for this tutorial. I want you to write a query that produces this result. So here we have these columns: order date, order ID, the first name of the customer, the shipper, and we can see that some of our orders are not shipped yet. So here we have null. And finally, the status. So go ahead, spend 2 to 3 minutes on this exercise. When you're done, come back, continue watching. All right, let's select everything from the orders table. Now we should join this with customers. On O.customer ID should be equal to C.customer ID. Here I'm using an inner join because every order does have a customer. So this condition is always valid. It doesn't matter if we use a left join or an inner join here, okay? Now, before going any further, let's pick our columns. So from the orders table, I want to pick order ID, followed by order date, and then customer.first name, which we can optionally rename to customer. All right. Next, we need to select the shipper. So we join the result with the shippers table on order.shipper ID equal to shipper.shipper ID. However, if we use an inner join here, because some of our orders don't have a shipper, we're only going to see the orders that have been shipped. Let me show you. So for clarity, I'm going to add the shipper's name here. So shipper.name as shipper. Let's execute the query. There you go. We only see the orders that have been shipped, but we want to see all the orders, right? So we need to change the second join to a left join. So all orders are returned whether they have a shipper or not. Let's execute the query one more time. There you go. Now we see all the orders from number 1 to number 10. Beautiful. Finally, we need to add the status column here. So we need to do another join here. Join with order statuses, which we abbreviate as OS, on o.status equal to os.order status ID. You can see that I have designed this database such that sometimes our column names are exactly identical, but in other cases, they don't match. So in the order table, we call this column status as opposed to order status ID. And this is deliberate because a lot of real databases are like that. All right, now let's add the status name here. So order status.name as status. Execute the query. And we can see all the orders here. For each order, we have the date, the customer, the shipper, and the status. Earlier, we talked about self-joins in SQL. So here in the SQL HR database, we have this employees table. We wrote a query to get all the employees and their manager. So here we have this column, reports to, that specifies the manager for each employee. So let's go back and rewrite this query to get all the employees and their manager. Back to our query editor window. First, let's use the SQL HR database. Then select everything from the employees table. We give it an alias and then join it with itself. So this is what we call a self-join. Now we're going to use a different alias like M for managers. Now, what is the join condition? E.reports2 should be equal to M.employee ID, right? Now for clarity, let's pick only 3 columns. So E.employee ID, E.firstname, and M.firstname, which we rename to manager. All right, let's execute this query and see what we get. So here's the result. As we can see, all these employees have the same manager. However, there is something missing here. We don't have a record for this person, this manager himself. So what is missing is a record where we can see the employee ID for this person, their name, and their manager, which should be null because this person is the CEO or the head of the company. But why is this happening? The reason is our inner join. Because this condition we have here will only return people who have a manager. We can solve this problem by using a left join. So we do a left join because we want to get every employee in this table, whether they have a manager or not. Okay, now let's execute the query one more time. There you go. Now we have a record for this person, the manager. As you can see, this person does not have a manager. That's why we have null here. Back to our SQL Store database. Here we have a simple query that joins the orders table with the customers table. And here's our join condition. You have seen several examples of this before. Now, as our queries get more complex, these join conditions get in the way. They make our queries hard to read. But the good news is that in Mysql, we have a powerful feature for simplifying these queries. If the column name is exactly the same across these 2 tables, we can replace the on clause with the using clause, which is simpler and shorter. Let me show you. So I'm going to comment out this line and instead type out using. In parentheses, we type out the column name, that is customer ID. What we have on line 7 is exactly identical to what we have on line 6, but it's shorter and easier to read. So let me delete this line. We can add another join statement here to join the orders with the shippers. So join with shippers using shipper ID. In both these tables, we have a column with the exact same name. All right, now let's execute this query. This is what we get. We have the order ID followed by the first name of the customer. Let's add a new column here. So I'm going to add sh.name. That is the name of the shipper. So shipper. Now, obviously, because some of our orders are not shipped, we need to replace this inner join with a left join. So we can use the using keyword with both inner and outer joins. Let's execute the query one more time. There you go. Now we have the name of the shipper next to each order. Beautiful. However, we cannot use this technique to join the result with the order statuses table. Because in the orders table, we have this column called status, but in order statuses table, this column has a different name. It's order status ID. Let me show you. So order statuses, columns, there you go, order status ID. So the using keyword only works if the column name is exactly the same across different tables. Now, what if we have multiple columns in our join condition? For example, earlier we talked about this order items table. I told you that in this table, we have a composite primary key, which basically means a primary key that consists of multiple columns. So the combination of these two columns uniquely identify each record in this table. Now, if you want to join this table with order item notes table, in our join condition, we should compare both these columns with their corresponding columns in the order item notes table. So let's quickly write that query and then simplify it with the using keyword. So select everything from order items. Now join it with order item notes on. So here we need to compare oi.order ID with oin.order ID and oi.product ID equal to oin.product ID. This join condition is kind of messy. It's hard to read this query. Now we can simplify this query with the using keyword. So we type out using. In parentheses, we add both columns and separate them using a comma. So order ID and product ID. Isn't that better? Now for exercise, back to our SQL invoicing database, write a query to select the payments from the payments table and produce something like this. So in this table, we have the date, the client, the amount, and the payment method. We can see on what date who has paid how much using what payment method. All right, I'm going to use the SQL invoicing database and then select everything from the payments table, join it with the clients table using client ID, because in both these tables, we have the client ID column. Next, we need to join this with payment methods. However, the column name between these two tables is different. So in the payments table, we have a column called payment method, but in payment methods table, our column is called payment method ID. So here we cannot use the using keyword, and we'll have to use the on clause. So on p.payment underline method equals pm.payment method ID. Now let's pick our columns. So payment.date, client.name, and we rename this as client. Next, we pick the amount, and finally the payment method. So let's rename that to payment underline method and execute the query. There you go. This is what we get: the date, the client, the amount, and the payment method. In Mysql, we also have another simpler way to join two tables. It's called a natural join and it's easier to code, but it's not something that I recommend because sometimes it produces unexpected results. But let me quickly show you how it works in case you see it somewhere, so at least you're familiar with it. So back to the previous example, let's select everything from the orders table. Now we should do a natural join with the customers table. Now with these natural joins, we don't explicitly specify the column names. So the database engine will look at these two tables and it will join them based on the common columns, the columns that have the same name. And that is the reason this query is shorter to write. So for clarity, let's pick a couple of columns here, o.order ID and c. Let's say first name. Let's execute the query. There you go. So we see all the orders and the customers who placed them. So natural joins are really easy to code, but they can be a little bit dangerous because we're letting the database engine figure out or guess the join. We don't have control over it. For this very reason, natural joins can produce unexpected results, and that's why I discourage you to use them. In this tutorial, we're going to look at cross joins in SQL. We use cross joins to combine or join every record from the first table with every record in the second table. Here's an example. Let's select everything from the customers table. Now here we do a cross join with the products table. So every record in the customers table will be combined with every record in the products table. And that is why we don't have a condition here. Okay, so this is what we call a cross join. Now for clarity, let's pick a couple of columns like c.first name. We rename it as customer, and then product.name, which we rename to product. Also, let's sort the result by customer.firstName. Now let's execute the query. Here's the result of a cross join. So first we have Amber as the customer, and here are all the combinations of Amber with different products. Next we have Barbara, or whatever it is, and again we have the combination of this customer with all the products. Now in this particular example, it doesn't really make sense to use a cross join. A real example for using cross joins is where you have a table of sizes like small, medium, large, and a table of colors like red, blue, green, whatever. And then you want to combine all the sizes with all the colors. That is when you use a cross join. Now what we have here is called the explicit syntax for a cross join. We also have the implicit syntax, which looks like this. Instead of typing out the cross join, we type out multiple tables in the from clause. So customers and orders. Both these queries produce the same result, but I personally prefer to use the explicit syntax because it's more clear. And here's a simple exercise for you. Do a cross join between shippers and products. First do it using the implicit syntax and then using the explicit syntax. It's pretty straightforward. I just want you to get your hands dirty in the code and get used to this syntax. All right, first I'm going to use the implicit syntax, and then I'll show you the explicit syntax. So let's start by selecting everything from two tables, shippers and products. Now for clarity, let's pick two columns, shipper.name, which we rename to shipper, and product.name, which we rename to product. And finally, let's order everything by shipper.name. Let's execute the query. This is what we get. So the combination of all shippers and all products. Beautiful. Now let's use the explicit syntax. So we select everything from the base table, in this case, shippers, and then do a cross join with products. That produces exactly the same result. We covered everything about joins. You learned that with joins, we can combine columns from multiple tables. But in SQL, we can also combine rows from multiple tables. And this is extremely powerful. Let me show you how that works. First, let's have a quick look at our orders table. So select everything from the orders table. Now, if you look at the data, we can see that the first order was placed in the current year, 2019. All the other orders were placed in previous years. Now let's say we want to create a report, get all the orders, and next to each order, add a label. If the order is placed in the current year, the label is going to be active. And if the order was placed in previous years, we want to label it as archived. So let's change our query and add a condition here. First, we want to get all the orders in the current year. So where order date is greater than or equal to 2019-01-01. Now, I just want to highlight that this is not the ideal way to get the orders in the current year, because here we have hard-coded 2019. So if we execute this query next year, we're not going to get the right result. But don't worry about this for now. Later in the course, I will show you how to get the orders in the current year without hard-coding a date here. So let's execute this query. Now we get only one order. Let's handpick a couple of columns here. So order ID and order date. And also I want to add a string literal here, like active, right? Let's execute this query. This is what we get. We have 3 columns, order ID, order date, and active. And in this column currently we have this string value, active. Now let's rename this column to status and execute the query. That is better. Now we want to write another query similar to this that will return the orders in the previous years, but with a different label, archived. So to save time, I'm going to copy these few lines and paste them right after our first select statement. Now note that here we have a syntax error because we didn't terminate the first select statement with a semicolon, but don't worry about it. We're going to get back to this in a second. So for the second query, we want to return a different label, archived, and we want to change our condition to less than 2019. Now, select only these few lines and execute this query either by clicking on this icon here or using the keyboard shortcut that you learned earlier in the course. So there you go. Here are all the orders from the previous years with the label archived. This query returns 9 records. The previous query returned 1 record. Now, using the union operator, we can combine data from these 2 queries. So in between our select statements, we type out union. Now let's execute the query one more time. So here's our first order in the current year that is active. And below that, we have all the orders in the previous years. So using the union operator, we can combine records from multiple queries. Now, in this example, both our queries are against the same table, but we can also have queries against different tables and then combine the result into one result set. Let me show you another example. So I'm going to delete everything here. Let's select the first name from the customers table, and then we can union that with select the name from the shippers table. Let's execute the query. So in one result set, we can see all the customers and all the shippers. Now, as far as I know, there is no real world use case for this particular query. But what I want to point out is that with union, you can combine results from multiple queries. These queries can be against the same table or different tables. In your database, you could have a table like archived orders and another table like orders, and then you could combine all the archived and active orders into one result set. Just remember that the number of columns that each query returns should be equal, otherwise you're going to get an error. For example, let's select the first name and last name from customers, and then union that with the name of shippers. When we execute this query, we'll get an error because the first part of this query returns 2 columns, but the second part returns 1 column. So Mysql doesn't know how to combine these records. And one last thing before we finish this tutorial. If you look at the result here, the name of this column is based on the first query. So the first query returns first name, and that's why this column is called first name. If we change the order of these queries and move this union up here, now let's run this query. As you can see, our column is called name. So whatever we have in the first query is used to determine the name of these columns. Here we can also rename the column to, let's say, full name. There you go. All right, here's your exercise for this tutorial. Write a query to produce this report. So here we have 4 columns, customer ID, first name, points, and type. Now, as you know, we don't have this column in the customers table. So we have calculated the values in this column based on the points each customer has. If they have less than 2,000 points, their type is bronze. If they have between 2,000 to 3,000 points, they are silver customers. And if they have more than 3,000 points, they are gold customers. Also note that here we have sorted the result by the first name. So go ahead and spend 2 minutes to write this query. All right, first let's get the bronze customers. So select everything from customers where points is less than 2,000. Now here we want to pick 3 columns, customer ID, first name, and points. And finally, we add a new column with a string literal bronze. Let's run this query and see what we get. So these are all the bronze customers, but the name of this column is bronze. We don't want that. So let's rename this to type. Now this is off the screen, so I'm going to break this up into multiple lines. That makes our query cleaner and easier to read. So there you go. Let's run the query one more time. Now the column is called type. Beautiful. Now we should do a union and repeat this query, but extract the silver customers. So I'm going to paste this query here and then make a couple of changes here. I'm going to replace bronze with silver and change the condition to between 2000 and 3000. Let's run our query and see what we get. So we have all the bronze customers first, followed by all the silver customers. So the order of these records are based on our queries. In our first query, we got the bronze customers. That's why they are listed first. But this is not what we want. We want to order the result by the first name of our customers. So let's apply an order by at the end. So order by first name. Now there is one more piece remaining. We should do a union one more time and write the query to get the gold customers. So I'm going to select these few lines and paste them here. Now let's change silver to gold and the condition to points greater than 3000. And finally, we do an order by. Let's run the query one more time. And here's the end result. Our customers are sorted by their first name. We see all the bronze, silver, and gold customers. In this section, I'm going to teach you how to insert, update, and delete data. Before we get started, let's have a closer look at our customers table. So click on this middle icon to open this table in the design mode. What you see here might look a little bit intimidating at first, but trust me, this is actually so easy. And in this tutorial, I'm going to explain exactly what we have in these columns. So on the left side, you can see the column name. Next to that, you can see the data type for each column. So our customer ID column can only accept integer values. Integers are whole numbers like 1, 2, 3, 4, and so on. They don't have decimal points. First name is a varchar, which is short for variable character. Now here in parentheses, you can see 50. That basically means in this column, we can have a maximum of 50 characters. Now, if the name of a customer is only 5 characters long, we only store those 5 characters. So even though the maximum length for this column is 50, we are not going to waste space if the customer's name is less than 50 characters. That is why here we have varchar, which is short for variable. In contrast, we have another data type that is character. If we had character 50 here, and the name of the customer was only 5 characters long, Mysql would insert additional 45 spaces to fill this column. So this is a waste of space. So as a best practice, most of the time we use varchar to store string or textual values. Now here on the right side, we have this column pk, which is short for primary key. So customer ID is marked as the primary key, and that is why we have this yellow key here. So the values in this column uniquely identify each customer. Next to that, we have NN, which is short for not null, and that determines if this column can accept null values or not. In this case, every customer record must have the customer ID, first name, last name, as well as these other attributes. But birth date and phone are optional. So in these columns, we can have null values. Now we have another column here, AI, which is short for auto increment. And this is often used with primary key columns. So every time we insert a new record in this table, we let MySQL or our database engine insert a value in this column. So essentially it gets the customer ID for the last row and it will increment it by 1 at the time we insert a new record. So if you look at the data, you can see that currently we have only 10 customers here. So if you add a new customer here, MySQL will assign 11 to the new customer, okay? And finally, here we have another column that specifies the default value for each column. For example, for our birth date and phone columns, the default values are null. So if we don't supply a value, MySQL will use the null values for these columns. Similarly, we have another default value for the points column. So if you don't supply the points for a customer, MySQL will use 0. Now, we have a few other columns here which are not important at this stage. You will learn about them later in the course. So now that you understand the attributes of each column in this table, let's go ahead and insert data into this table. In this tutorial, you're going to learn how to insert a row into a table. For that, we're going to use the insert into statement. Where are we going to insert this row? Into the customers table. So we type out the name of the table here, followed by the values clause. And here in parentheses, we supply the values for every column in this table. So back to our table definition, these are all the columns. First, we need to supply a value for the customer ID column. However, in this column, the auto increment attribute is enabled. And as I told you before, if we don't supply a value, MySQL will generate a unique value for us. So we can go back to our statement and either assign an explicit value or use default to let MySQL take care of generating this value. And this is the preferred approach. Because if you use an explicit value like 200, it is possible that you might have another customer with the same ID. So when you execute this statement, you're going to get an error because you cannot have duplicate values in this column. Every value should be unique. So here we're going to use the default keyword to let MySQL generate a unique value for the customer ID. Now, after that, we need to supply a value for the first name and last name columns. So let's say John Smith. Note that I have enclosed these values with quotes because as I told you before, in SQL, we should always enclose string and date values with quotes, either single or double quotes, okay? Now, what else? Back to our customers table. After the last name, we have the birth date. However, as you can see, this column is optional because this checkbox is not checked. So here we can use null or an explicit value. Null means the absence of a value. So back to our statement, we can type out a birth date like 1990, January 1st, or we could use the null keyword to leave out this value. Now in this demo, I'm going to use a valid date. Now to make this code cleaner and more readable, I'm going to break it up into multiple lines. That's better. Now back to our table. Next we have phone, and phone is also optional because this checkbox is not checked, and null is the default value for this column. So here we can explicitly pass null or use the default keyword and let MySQL put null into this column. It's exactly the same. So back to our statement, we can pass null or default. Both these keywords will have the same result. In this case, I'm going to use the null keyword. All right, let's have one more look at our table. Next, we have 4 more columns that are required. So address, city, state, and points. And note that points has the default value of 0. So we can either use an explicit value like 200 or use the default keyword and let MySQL generate 0. So back to our statement. Let's type out an address. It doesn't really matter. Followed by a city and a state, let's say California. And finally, points. Again, we can use an explicit value or default. So this is how we can insert a row into a table. However, in this example, we are only supplying values for first name, last name, birth date, and these address fields. So we're leaving out the phone number, the customer ID, and the points. So there's another way to write this statement. Let me show you. So after the table name, we can optionally supply the list of columns that we want to insert values into. In this case, first name, last name, birth date. Now, once again, I'm going to break up this statement into multiple lines. So 3 more columns, address, city, and state. So these are the 6 columns that we're going to supply values for. With this change, we don't have to use these default or null values. We only supply values for these columns. So I'm going to remove default from here, then null, and finally this last default keyword. So these 6 values that we supplied here are used for these 6 columns. Now with this change, we can also reorder the columns. We don't have to list them in the same order that they are defined in the customers table. For example, we can put the last name first, and then obviously we should also swap the order of these values, so we can list them in any orders. Now let's execute this statement. Now if you look at the output window, down the bottom, you should see the statement followed by 1 rows affected. Unfortunately, I cannot resize this window to show you this message, but if you look down below, you can see that 1 record was affected, which basically means 1 record was inserted into this table. Now let's look at the data in the customers table. So the last row is the one that we inserted. You can see that Mysql automatically generated the value 11. This is the effect of auto increment attribute. So it takes the value of the last row and increments it by 1. So here we have the first name, last name, the birth date. We didn't supply a value for the phone attribute, so that's why we have null here. We also have address, city, state, and the default value of 0 for the points. In this tutorial, you're going to learn how to insert multiple rows in one go. For this demo, we're going to use this shippers table. Let's have a quick look at the table definition. So here we have 2 columns, shipper ID and name. Shipper ID is a primary key. It's not nullable, and it's an auto-incremented column. So we're going to let Mysql generate values for this column. Easy. We only need to supply a value for the name column. So back to our query editor window, we type out insert into shippers. In parentheses, we specify the name of the columns we want to insert values into. In this case, name, followed by the values clause. Here we add a pair of parentheses with a value like shipper1. Now to insert multiple rows, all you have to do is to add a comma followed by another pair of parentheses. So shipper2, and one more time, comma, parentheses, shipper3. This is how you can insert multiple rows in one go. Now let's execute this statement. All right. And then inspect the data in the shippers table. There you go. So initially we had only 5 shippers, and here are the 3 new shippers that we inserted. Note that Mysql automatically generated the values for the shipper ID column. So we have 6, 7, and 8. All right, here's your exercise for this tutorial. Write a statement to insert 3 rows in the products table. That's pretty easy. You can knock it out in a minute. So here's our products table. We only have 4 columns. We're going to leave out the first column because it's an auto-incremented column. So we only have to supply values for name, quantity, and unit price. Back to our query editor window. Let's insert into products. The columns are name, quantity in stock, and unit price. And the values are going to be, let's say product 1, stock is going to be 10, and the unit price is going to be 1.95. Now I'm going to select these values, copy, comma, paste it like this, change the values accordingly, and finally the last row, product 3. There you go. Let's execute this statement. All right, and then verify the result. So in the products table, now we should have 3 new records. Now the IDs you see here are 15, 16, and 17, because before recording this video, I actually inserted a few records in this table and then deleted them. So I had product IDs 11, 12, 13, and 14. Now, even though they're actually deleted from this table, Mysql remembers their IDs. So instead of incrementing 10 by 11, it incremented 14, which was the last record from before, and that's why it generated 15. On your computer, the IDs are going to be 11, 12, and 13. So far, you have only learned how to insert data into a single table. In this tutorial, I'm going to show you how to insert data into multiple tables. Here's a really good example. Look at the orders table. What columns do we have here? We have the order ID, we have the customer ID, so we know who has placed this order, we know the date of the order, we know the status, comments, as well as shipping information. but the actual items for this order are not in this table. They are in the order items table. So in this table, we have 4 columns. We have the order ID, so we know what order this item is for. We have the product ID, so we know what product has been ordered, at what quantity, and what price. So an actual order can have one or more order items. This is what we call a parent-child relationship. So in this relationship, the orders table is the parent and the order items table is a child. So one row in the orders table can have one or more children inside the order items table. Now in this tutorial, I'm going to show you how to insert an order and all its items. So you will learn how to insert data into multiple tables. All right, back to our query editor window. First, we need to insert the order. So insert into, let me close the navigator panel. All right, we want to insert a record into the orders table. Now, what columns do we have here? So we have these columns, but only the first 4 are required. And actually the first one, we don't want to worry about that because that's an auto increment column. So we only want to supply values for customer ID, order date, and status. So back to our query, we specify those columns here: customer ID, order date, and status. Now let's supply the values. In the customer ID column, we need to add a valid customer ID. So let's have a quick look at our customers table. There you go. In this table, we have 11 records. So these are the valid customer IDs. Now back to our query, let's use 1 for customer ID, and then 2019, January the 2nd for the order date, and 1 for the order status. Once again, in this column, we need to insert a valid order status ID. If we don't supply a valid ID, Mysql is going to yell at us. So we insert an order here. Now we need to insert the items. Now back to our order items table. In this table, we have this order ID column. So here's the tricky part. As soon as we insert an order, Mysql is going to generate an ID for our new order. Now we need to be able to access that ID in order to insert the items in this table. How can we do that? Well, back to our query editor window. In Mysql, we have a bunch of built-in functions, and a function is basically a piece of code that we can reuse, just like the functions or features in your TV. Every TV comes with a bunch of built-in functions like power on, power off, change the volume, change the channel, and so on. So Mysql and other database engines come with a bunch of built-in functions that we can use in our programs. One of these functions is last insert ID. We can call or execute this function by adding parentheses here, and this will return the ID that Mysql generates when we insert a new row. So before going any further, let's just select this and make sure we get the right result. Now we have a syntax error here because we didn't terminate the first statement with a semicolon. All right, now let's execute this query. All right, so the ID of the new order is 12. Let's verify that. So back to the orders table. Let's look at the data. On my machine, I have 12 records here. I actually created one just before recording this video. So on your machine, you're going to have 11 orders. Now back to our query window. Now that we know how to get the ID of the newly inserted record, we can use that ID to insert the child records. So we're going to write another insert statement, insert into order items. Let's have another look at the columns in this table. So we have 4 columns and all of them are required. So there is really no need to specify the column names in our insert statement. We simply supply values for order ID, product ID, quantity, and unit price. So here in the values clause, we add parentheses. What is our order ID? That is the value returned from calling this function. So I'm going to cut this from here and put it here. Next, we need to supply a valid product ID. Let's say product 1, quantity, let's say 1, and the unit price, $2.95. Now let's delete this select. We don't really need it anymore. And let's add another set of values. So once again, we're going to call last insert ID to get the ID of the new order. We're going to change the product to product number 2 and add a different price. That's it. Now let's execute these statements and see what we get. All right. So Back to our orders table. Let's refresh the records here. All right. So we have a new order, order number 13. Beautiful. Now let's look at the order items table. Here's the order items. Let's open the table. So we should have 2 items for order number 13. Beautiful. So this is how you insert hierarchical data in MySQL. In this tutorial, I'm going to show you how to copy data from one table to another. For example, in our orders table, currently we have about a dozen records. Now let's say we want to create a copy of this table called orders archived, and we want to insert every row that we have in this table into that new table. If we have 10 orders, we don't want to code an insert statement with 10 set of values. That is very time consuming. So I'm going to show you a powerful technique to quickly copy data from one table to another. First, we need to create this new table, orders archived. For that, we're going to use the create table as statement. So create table orders archived as. Now, right after that, we write a select statement to get everything from the orders table. Now, let's see what happens when we execute this query. There you go. So back in the navigator panel, we have to refresh this view by clicking on this icon over here. Now we have a new table, orders archived. Let's look at the data. So you can see all the orders are here, and we have the exact same columns as the orders table. However, if you open this table in the design mode, you can see that in this table, we don't have a primary key. So the order ID column is not marked as a primary key. And also it's not marked as an auto increment column. So when we create a table using this technique, MySQL will ignore these attributes. And that means if you want to explicitly insert a record into this new table, we have to supply a value for order ID because this column is no longer an auto increment column. Okay. So using create table as statement, you can quickly create a copy of a table. Now we refer to this select statement as a subquery. So a subquery is a select statement that is part of another SQL statement. Now we can also use a subquery in an insert statement, and that's a very powerful technique. It allows us to do really cool things. Let me show you. So first, let's right-click the orders archive table and click on truncate table because we want to delete all the data in this table. All right, it's asking for confirmation. Let's truncate the table. So now back to this table. Let's refresh the table. We don't have any records here, okay? Now back to our query editor. Let's say we want to copy only a subset of records from the orders table into this table, like all the orders placed before 2019. So first, let's select everything from the orders table where order date is less than 2019, January 1st. So these are all the orders number 2 to 10. Beautiful. Now we want to copy these orders into the orders archive table. So we can use this select statement as a subquery in an insert statement. We write insert into orders archive. Now we don't need to supply the column names because we're going to supply values for every column that we have in this query. So we delete that, and this is an example of using a select statement as a subquery in an insert statement. Let's execute this. All right, now back to the table. Let's refresh the records. We only have the orders placed before 2019. All right, here's a really cool exercise for you. Back to our SQL invoicing database, look at the invoices table. So in this table, we have these columns, invoice ID, number, client ID, which is associated or related to the client ID column in the clients table, followed by a few other columns. Now, let's say we want to create a copy of the records in this table and put them in a new table called invoices archived. However, in that table, instead of the client ID column, we want to have the client name column. So you need to join this table with the clients table and then use that query as a subquery in a create table statement. Also, to make the exercise more interesting, I want you to copy only the invoices that do have a payment. So if you look over here, this payment date column determines if a payment has been made towards this invoice or not. So select only the invoices that do have a payment date. It's a really, really good exercise. Spend 2 to 3 minutes on this and then come back, continue watching. All right, first I'm going to use the SQL invoicing database. Now let's select everything from the invoices table and join it with the clients table. Here I'm going to use the using statement to simplify my join. What column are we going to use for joining? The client ID column. Let's execute this query up to this point. All right. So first we see the client ID column that is used for joining these tables. After that, we have the columns from the invoices table, like invoice ID, number, and so on, followed by the columns from the clients table, like name, address, and so on. Obviously, we don't want all of these columns. We only need the columns from the invoices table, but we should replace the client ID column with the client name column. So let's have a quick look at the design of the invoices table. Here we have invoices ID, number, client ID. We want to replace this column with the client name. So back to our query. I'm going to pick invoice ID, number, and then client.name. Let's rename it to client. What other columns do we have here? We have invoice total and payment total. So let's add those as well. Invoice total as well as payment total. We also have 3 columns for dates: invoice date, due date, and payment date. So let me close the navigator panel. Invoice date, payment date, and due date. Now, technically, because these columns only exist in the invoices table, we don't have to prefix them with a table alias. So we could simplify the code like this. However, I personally prefer to prefix them because that gives me a more clear picture of how I'm joining these tables. It's just a personal preference. Another developer might disagree, and that's perfectly fine. So whatever you prefer, that's perfectly fine. Let's execute the query and make sure we get the right result. So we have the invoice ID, number, client, beautiful, followed by these other columns. Now we want to filter the result and return only the invoices that do have a payment. So we can either return records that have a payment date or the records that have a payment total of greater than 0. Both are perfectly fine. So back to our query. Down the bottom, let's add a where clause where payment date is not null. That's better. Let's execute the query one more time. Now we get only this handful of invoices. Beautiful. Finally, let's use our query as a subquery in a create table as statement. So right before select, we type create table, invoices archived as, there you go. Let's execute the query. Beautiful. Now back to the navigator panel. Let's refresh the view. So here's our new table, invoices archived. Let's look at the data. There you go. We only have the invoices paid, and here's the name of the client for each invoice. Beautiful. Now just note that if you execute this query one more time, you're going to get an error because we already have a table called invoices archived. Later in the course, I'll show you how to drop tables. That's pretty easy. But for now, you can just right click and go to drop table and then confirm. All right, and then you can run the query one more time. In this tutorial, I'm going to show you how to update data in SQL. So back to our invoices table. Look at the first record here. The payment total for this record is 0, and obviously there is no payment date. Now let's imagine that there was a problem in the system that recorded this information. Let's say the client paid $10 for this invoice. So we should update this record in this table. That is very easy. Back to our query editor window, we use the update statement to update one or more records in a table. What table? In this case, invoices. Next, we add the set clause, and this is where we specify the new value for one or more columns. In this case, we want to update payment total. Let's set it to $10. We should also update payment date. So we use a comma to add more columns. We set this to a date value. Let's say 2019, March 1st. And then we type out a condition. With this condition, we identified the record or the records that need to be updated. In this case, we want to update the invoice number 1. So back to our query, we type out invoice ID equal to 1. Let's execute this. Beautiful. Now back to our table. Let's refresh the data by clicking on this icon. All right, you can see payment total is updated to 10, and we also have a payment date. Beautiful. Now let's say we actually updated the wrong record. Maybe we should have updated invoice number 3. So we should update this table one more time and restore the original values in these columns. Back to our query, we can set the payment total to 0 and the payment date to null. So we can use the null keyword to insert the null value in a column that accepts null values. Now back to the navigator panel, let's open this table in the design mode. You can see that the payment total column has a default value of 0 and the payment date column has the default value of null. So back in our query, we can also set payment total to default, and MySQL will use the default value for this column, which is in this case 0. So let's execute this statement one more time. Beautiful. Now back to the table, let's refresh the data. So payment total is set to 0 and payment date is null. Beautiful. Now let's go ahead and update the third payment. Look at the invoice total. That is $147. For this example, let's imagine that the client made 50% of the total amount on the due date. So back to our query editor window, instead of using a literal value here like $70, we can write an expression. We want to calculate 50% of invoice total. So invoice total times 0.5. Now let me break this code into multiple lines so we can see clearly. Now we should set the payment date. As I told you, this client made the payment on the due date. So we can set this to due date. Whatever value we have in this column will be used to set the payment date. And obviously we need to update the invoice ID, number 3. Now back in the table, let's refresh the data. All right, look, payment total is updated and it's set to almost 50% of the invoice total. However, this number is truncated, so we don't have the digits after the decimal point. Don't worry about it for now. We'll come back to this when we talk about data types later in the course. Also, we can see that payment date is set to the same value we have in the due date column. In the last tutorial, you learned how to update a single record using the update statement. Now, if you want to update multiple records, the syntax is exactly the same, but the condition that you type out here has to be more general. For example, back to the invoices table, you can see that we have multiple invoices for client number 3. We can write a statement to update all the invoices for this client. So back to our query editor window, we change our condition to where client ID equals to 3. However, if you execute this statement with MySQL Workbench, which is the software we've been using in this course, you're going to get an error because by default, MySQL Workbench runs in the safe update mode. So it allows you to update only a single record. You're not going to have this problem if you use another client for MySQL or if you write this statement in your application code. This is only specific to MySQL Workbench. Now let me show you how to get around this. So on the top, we go to MySQL Workbench menu and then Preferences. On this dialog box on the left side, click on SQL Editor. And then down the bottom, untick this checkbox, Save Updates. So this prevents you from accidentally updating or deleting a bunch of records in a table. So let's go ahead with this. Now we need to reconnect to this instance of MySQL. So let's copy all the code here and close this local instance window. All right. Now on the home page, double click this connection to reconnect. There you go. And then paste all that SQL code. Now let's execute this. Beautiful. all the invoices for client number 3 were updated. Here we can also use the in operator. Let's say we want to update all the invoices for clients number 3 and number 4. So all the operators you learned to use in the where clause also apply here. Now, technically, this where clause is optional. So if you want to update all the records in a table, you simply leave it out. All right, here's your exercise for this tutorial. Back to our SQL Store database, write a SQL statement to give any customers born before 1990 50 extra points. All right, first I'm going to use SQL Store, then write an update statement to update the customers table, set the points to points plus 50. So here we're using an expression to update the points column for anyone born before 1990. So where birth date is less than 1990, January 1st. All right, let's execute this query. All right, now let's open up the customers table one more time. So anyone who was born before 1990 now has an extra 50 points. In this tutorial, you're going to learn how to use subqueries in an update statement. That's extremely powerful. So we're going to continue with the example from the last tutorial, but we're going to make it more interesting. Here we're updating all the invoices for client number 3. But what if we don't have the ID of a client? We only have the name. For example, imagine you have an application, and in that application, the user types in the name of the client. So first, we should find the ID for that client, and then use that ID to update all their invoices. How do we do that? Well, let's have a quick look at our clients table. So here we have this client, MyWorks. Let's say we have the name. We want to find the ID. So back to our query editor window. After this update statement, I'm going to write a select statement to select the client ID column from the client's table where name equals MyWorks. Now here we have a syntax error because we didn't terminate the last statement with a semicolon, but don't worry about that. We're going to get back to that in a second. Let's just select these few lines and execute this query. The ID of this client is 2. Beautiful. Now we can use this select statement as a subquery in an update statement. So as I told you before, a subquery is a select statement that is within another SQL statement. So instead of hard coding 3 here, we're going to use this select statement as a subquery, but we need to put it in parentheses. So Mysql will execute this query first. It will return the client ID and then use it in this condition. So for clarity, let's remove the line break and indent these few lines. So this is the end result. Now we execute this query, and this updated all the invoices for this client. Now, what if this query returns multiple clients? For example, back to the clients table, let's imagine we want to update the invoices for all clients located in New York or California. So we need to update our subquery like this, where state in California and New York. Now, before executing the entire statement, let's just select our subquery and execute it to see what we get. So we get 2 client IDs, 1 and 3. Beautiful. Now, because this query, this subquery, returns multiple records, we cannot use an equal sign here anymore. So we need to replace this with the in operator. And now this statement updates the invoices for all clients located in these 2 states. Let's execute it. Beautiful. Everything worked. So as a best practice, before executing your update statement, run your query to see what records you're going to update, so you don't accidentally update the records that shouldn't be updated. Now here we have a subquery, but even if it didn't have a subquery, we could still query the records that we're going to update. Let me show you. So let's imagine we're going to update all the invoices where payment date is null. Before executing this entire update statement, I would run a query like this. Select star from invoices where payment date is null. Now let's execute this query. These are the two records that don't have a payment date. So once we're confident that we're updating the right records, then we come back here and get rid of this select statement and just attach the where clause to our update statement. All right, here's your exercise for this tutorial. Back to our SQL Store database, look at the orders table. As you can see, some of our orders don't have a comment. I want you to write a SQL statement to update the comments for orders for customers who have more than 3,000 points. So customers who have more than 3,000 points, we regard them as gold customers. Find their orders. If they have placed an order, update the comments column and set it to gold customer. That's a really good exercise. All right, first we need to find the gold customers. So select everything from the customers table where points is greater than 3,000. And by the way, because the current database is SQL invoicing, we either have to type out a use statement on the top or double click this database before executing this query. So there you go. We have 3 gold customers. Now we need to get the ID of these customers to use them in an update statement. So we only select customer ID here, and then use this select statement as a subquery and an update statement. So update orders, set comments to gold customer, where customer ID, because we're dealing with multiple customer IDs, we need to use the in operator. And then to use this as a subquery, we need to enclose it in parentheses. That's it. Let's indent the code. That's better. So here's the final solution. So you have learned how to insert and update data. In this lecture, we're going to finish this section by learning how to delete data. That is very easy. We use the delete from statement to delete records from a table. Let's say the invoices table. Now, optionally, we can add a search condition to identify the records we want to delete. If you don't write this where clause, with this statement, we'll delete all the records in this table. And obviously, that's very dangerous. So be very careful when executing this statement. Now here, let's say we want to delete the invoice with the ID 1. So where invoice ID equals to 1. Now here we can also use subqueries. Let's say we want to delete all the invoices for the client called MyWorks. First, let's find this client. So select everything from the clients table where name equals to MyWorks. Let's execute the second query. So here's our client. Now we can get this client ID and use it in our search condition. So where client ID equals to, this is where we add our subquery. There you go. Just like before. Beautiful. So this is how we can delete data in SQL. All right, we're done with this section. But before going to the next section, I want you to restore all these databases to their original state. Because in this section, we added some data, we updated some data, we deleted some records. So if you don't restore these databases, you might see different results going forward. So restoring these databases is pretty easy. Here in Mysql Workbench, on the top, go to the File menu and open SQL script. Then navigate to the directory where you stored the SQL scripts for this course. In case you lost that directory, go back to the first section. We have a lecture for downloading the supplementary materials. So in this directory, open create databases.sql. Now execute this script to recreate all of our databases. All right, beautiful. Now let's open up the navigator panel. You can see the databases disappeared from here. Simply click on this refresh icon. Beautiful. All right, we're done with this section.